And there we go. What's that saying? Recording in progress. And prior to that, worked about 5 years in police and children's social care, doing child protection data and bits and pieces around that. So yeah, personally, really passionate about getting away from KPIs and using things like operational research and data and science to improve our services. My data science journey started, I think I was providing some data for Sean for a dementia model he was doing, and then we got chatting. Then I think I went on an Excel course with Dan to do some very basic Q modeling and geographic analysis. Again, all in Excel with amazing nested if match statements that went on for about 500 miles long. Which was fun. I asked Dan to dig out that training again at some point. For some reason, they don't do that anymore. But anyway, and sort of going on from that, I was really fortunate to get into the second HSMA, where really opened my eyes much further into sort of operational research and data science. And last year, I completed my master's in healthcare data science at Exeter University. So yeah, really keen on data science and all the cool stuff, and hopefully you guys are too. I've been using R for about 3 or 4 years now, very much coming from sort of a SQL and Excel background. I've used Python a fair bit, mostly with the HSMA and MSc, but my day-to-day love is definitely within R for sort of just general operational reporting, and especially if you're sort of coming from that SQL Excel background, it's probably makes a little bit more sense than Python, but obviously you guys are all Pythoneers. So where are we? Icebreaker, probably haven't got time for your icebreakers, but yeah, if you can just give us the long number on your credit card, your mother's maiden name, and the 3 figures on the back, that would be a good little icebreaker to put in the chat. Other than that, if you could put in the chat very briefly your current knowledge of R, any other scripting languages, which I'm assuming most of you are sort of Python, but if you have got any Excel, also or SQL, advanced Excel, etc. And possibly, and although this probably might be for sort of later on, if there's any sort of specific areas or things you'd like us to cover, but I think we're going to go over that more at the end of the session, because I think the next session we can make a little bit more, hopefully get a bit more time to be a bit more fluid around sort of outputs and what we want to do. Can't guarantee that we can sort of obviously cover everything within 2 days, but hopefully maybe I'll sort of signpost you where to get additional support or resources or further training if you need it. We've got quite a packed itinerary for you, but we will take comfort breaks throughout. This is very much going to be sort of hand-on teaching along, code along training. There are going to be some elements where we'll sort of code together, copy what's on the screen, and hopefully an opportunity then for you to sort of test out what you've learned as we go on. So just try to make sure you've got sort of free access to sort of 2 screens, one showing what's going on there on when I share my screen, and obviously your own screen. I will try to keep an eye on the chat. I think I have actually got that on my screen, so I can see that coming up. That's probably going to be the preferred method of shouting at me. Or the alternative method of shouting at me is literally shouting at me. I don't assume you guys can come off mute and just shout. Otherwise, I will just wobble on for hours and hours and hours. So yeah, do shout, do put stuff in the chat. I think I can sort of see it whizzing by. But yeah, and if there's anything really urgent, then yeah, please literally do shout. So yeah, as I said, this is hands-on sort of as we go along. Many of the lessons sort of build on top of each other. So if your code doesn't work or you get stuck, please shout, because we don't want to be sort of left behind and then the next bit's not going to work and then the next bit. So just make sure you are up to speed at all times. If you are really stuck, then be prepared to sort of share your screen, and we can have a look at what's wrong, and hopefully as a collective see what's happened. obviously everybody learns from mistakes. So if everybody makes lots of mistakes, we can all share our mistakes and learn from each other, which obviously improves all of our knowledge. So please make lots of mistakes and please share them with everybody else. We no doubt lots of common things. You guys have obviously done loads of Python, so at least hopefully you've kind of got over a little bit of that hurdle around case sensitivity. I know when I started learning sort of programming languages, either Python and R, especially coming from a SQL and Excel background, Microsoft teaches you terrible habits of case sensitivity, and hopefully that won't be your biggest hurdle, but I know it does kick people quite severely, especially when they're starting. And that's probably all I've got to say as an introduction. So we will be using RStudio Cloud. I will just pop a link to that in the chat, which is, if you haven't already, please let's see, go in there, look at that. Please log in if you can. Essentially, all you need is a Google account and you should be able to log in as a free user. We're not going to be using any sort of collective thing. We're all going to be using our own accounts, and we're going to be setting up as we go, just to make sure what's what. If anybody is using their own personal downloaded version of RStudio, there will be a few bits that are tweaked and slightly different for you, but I will assume that you're using the cloud version. It just means that we're all using exactly the same version, because I know, especially if you're using your NHS computer, then sort of version control and who's using what becomes really quite a challenge, as I'm sure you've all encountered. So without further ado, let me share my screen, which is that one there, isn't it? And I want to show that one there. Oh, got to press the share button. There we go. Right, so that, yeah, that should be showing. Okay, so introduction to R and RStudio. That's a general agenda. This isn't exactly the agenda we're going to be following. We're going to be tweaking that, so ignore that one. So course aims, definitely has to show you some of the possibilities, show you how it sort of all works, and hopefully give you enough that you can then go on and find sort of further information if you want to carry on doing some R. So what can R do? It can do some beautiful, elegant graphics and sort of sort of various different ways, and there's some really nice plotting modules, and we're going to be sort of building up some sort of quite basic plots today, but obviously we will try to make those a little bit more interesting. It can do sort of beautiful maps and sort of heat maps, etc. Obviously doing scripting languages is all about sort of collaboration, definitely about reproducibility, and there's also sort of the R Markdown. So R's got this lovely interface with R Markdown and Quarto, which allows you to sort of create your analysis a little bit like a Jupyter notebook, but then to actually produce a final output, which is got all your sort of charts and tables. They can be sort of interactive, and you can sort of have drill downs, etc. And they can then sort of go out as an interactive standalone document. So you can create sort of really nice reports and sort of send those over to users as a standalone interactive document, which is a really powerful thing to be able to do, to be able to sort of pull in all your data, do all your wrangling, create all these, and create a report all in one sort of reproducible way. Obviously lots of sort of automated reports. There are sort of plugins for sort of dashboards, and you can sort of use dashboards, and you can use R Shiny to make sort of much more sort of interactive dashboards that sort of link up to servers and have a more sort of traditional dashboardy thing if that's what you wish to do. And there's a couple of the very, very basic examples there. You can link your R up to SQL. Obviously, mileage and that varies depending on where you are and how your specific data warehouses are set up, but you can link R directly through to your SQL database, which again makes it that sort of really nice one-stop shop. Inclusively, there's a fantastic R community. Obviously, we are part of the NHS R community, which is very much a community based around R within the NHS, sort of promoting that. And obviously, there's things such as a conference, etc., and a very active Slack channel. The course philosophy. I remember this lovely cartoon when we were doing our Train the Trainer, trying to work out what this means. But what we are trying to say is we're not going to start at the basics and then, you know, go right through and build your sports car, and everything in between is not going to be useful. So we're not going to be ending our day with a sports car. What we're going to do is build up in a really, really sort of modular way, bit by bit. But hopefully, as we go along our journey, each little stage of our journey is actually quite useful and will help us go that little bit further and faster. So again, that's a really, really useful thing. So course philosophy.
Simon, sorry to interrupt. Oh, hello, sorry. Just sorry to interrupt, Simon. There's something come up the chat. Is there any way that you can mute your Teams notifications? I think a couple of people.
Oh, good grief. Yeah. How do you mute them?
Don't ask me. That's
no.
Just worth just closing it because it won't recognise that you're on another meeting and sharing because we're on Zoom.
If I put it on Do Not Disturb, that might help, mightn't it?
Yeah, people have said Do Not Disturb. Apparently, that's
all right. I'm doing that now. Sorry, it's somewhere. Where is it? No, it's all right. I'll get back to Teams in a minute. Sorry about that. Course philosophy, very relaxed and informal. That's me. All the slides, code, etc., are sort of going to be available. Let's put that on a Do Not Disturb. Bang. Right, hopefully that will shut up. And just generally, as you say, it's you've had lots of days in Python, and I'm sure you'll sort of have lots of experience in that. Obviously, there's going to be a very limited to what we can get through in a couple of days. So let's begin. So there's R and R Studio. Obviously, R is the R programming language. R Studio is your software application that sort of sits around that. No doubt you guys have been using, I don't know what you've been using actually, either VS Code or Spider or something like that. So obviously you've got your core language, and then obviously you've got a nice GUI that sort of sits around it and does nice things. Or if you've been using Python notebooks, etc. So R Studio is just there to sort of really, really help your programming experience. So R is your sort of stripped down, raw beast of a thing, whereas R Studio is much more. So you've got your airbags, and you've got your sat nav, and you've got your indicators, and lots of really nice things to sort of help make your driving experience that little bit nicer. So generally, we're going to be using R Studio, so we don't need to think about sort of R as a separate thing. And that's that. So let's get into our studio. So we should have our Posit Cloud, and I should be able to make that larger, that's the word. And let's log in. I'm going to log in with Google because I've already got a Google account. And that's me there. Please shout if there's any problems so far. And it will come up with a workspace. Yours will probably be empty. Mine's full of mess. So once you get to that stage, you want to click up here where it says new project. I'll give 2 minutes for people to catch up. So that was simply going into RPosit. Hopefully you've already got an account and you just log in with your Google credentials and away you go. And it should bring you to a workspace, and yours is probably up here all empty. I definitely need to get rid of some of mine. Please shout if anybody's got any trouble at that stage. Nope, assume not. Cool. Actually, oh yeah, look at that. I can put my chat somewhere else. So clever. Where is it on GitHub? Is it there now? Yes, it is, and I'll put the links in at the break. So hopefully everybody is there. So if you go onto new project, it will give you a couple of options. We want the RStudio project. There is an option to start a Jupyter project if we so wished, and you can use RStudio. So RStudio being the GUI, you can use RStudio to do Python-y stuff if you like the GUI, and also you can sort of link directory to a GitHub repository and sort of build stuff for there. But what we are going to do is a new RStudio project. And that should start loading and deploying. And it should do something very shortly. There we go. So if anybody's used Spider before, it's very similar to Spider in its initial look, or a little bit like, yeah, it's more like Spider than it is VS Code. So there we go. Right, let's just go back to, where are we? No, we're on this one, aren't we? So we've got RStudio. We've got several different bits. We've got a console where we can just basically, it's a straight console window through to R. So we can do some very, very basics. We can do 1 + 1, and R will use its amazing potential to tell us the answer to such things. I do believe it is traditional to do a print hello world. And we get a hello world. Everybody got anybody not got to hello world stage? Oh, no, that's good. So that's very much about we sort of input a command and it comes out straight away and comes up with an answer. Obviously, and I'm sure you guys are way beyond me that actually we don't want to write our code line by line. We want to make ourselves a nice script that will run through and obviously have a nice bit of reproducible script that we can then share with other people. So we want to choose create an R script. So up here on the top right hand side, actually just before we start going much further, I'm just going to make my stuff a little bit bigger for you. Where are we? Appearance. Okay, sorry, I hope that's a little bigger. But up here, there's a little blue, sorry, colorblind green plus, which says new file. If we click on that one, it gives us various different options of different files that we can create. And what we want to create is an R script. So it does give us some various options. I'll just sort of run through this quickly. There's a Quarto document or Quarto presentation. That's if we want to create a report, which basically that's where I was talking about sort of creating that sort of standalone type report, which you can then sort of share. You can either set that as a document, or you can create sort of presentations, which again, sort of all interactive and you can change through. The training slides, which I'm sort of showing at the moment, those are all written in sort of a Quarto and a Markdown, so you can sort of flick through them and see what's going on there. You can use an R notebook, which is pretty much a version of Python notebook. You can use R Markdown, and there's sort of various other bits and pieces, and we can obviously do different Python scripts and all those other different bits and pieces. But we want the top one, which is a very, very basic R script. You can also press Control Alt Shift and N as a shortcut and create us a script. So this is the editor, this is the console. So now we can do our 1+1 and press enter, and seemingly nothing happens. However, if we want to actually send that line to the console, we can either press Control and enter and it will run that script, or we can sort of highlight over where we want to go and we can do our run, and that will also run our script. I think it works in a very similar way to Spider. I can't remember what VS Code does, but I think it's sort of very, very similar. So I'm sure you're very, very used to sort of running script in that way. So obviously the most important command that you're going to learn is the hash command, which is how we write comments. So this is a comment. Obviously comments are not evaluated when you run your code. They are there to just have an idea of what's going on, and they're also there for future you to read back when you come back to your code to try to work out what you've done. I know for a fact that future Simon is a complete idiot, so I have to write him really, really well documented code to try to explain what I'm doing, because when he reads back, he's like, what has past Simon done here? So, he thinks past Simon's an idiot, but you know, that would be me now, and that all gets really, really confusing. Anyway, future Simon is definitely an idiot, so I have to write him lots and lots and lots of comments about what's going on, and I would fully recommend that commenting is free and doesn't take up anything, and it's just a fantastic thing to do. So just comment your code as much as you possibly can. Nobody is going to go, oh no, your code was far too commented and told me far too much of exactly what was going on. You know, that's never going to be a thing. So comment your code as best you can is really, really good advice. So we've got our editor here where we're writing our script, and we've also got a console. Just a few things that we are going to change. So if we go back into our tools and global options, there's a couple of bits and pieces that are worth noting. So one of which is our workspace, which is this one here. So R does a very useful but also very dangerous thing. This was our studio. So when you save your, what it can do is it can take a snapshot of your environment as it is and save it as is, which means any data that you've loaded, any variables that you've created, all of that is saved as a sort of a snapshot, which is kind of really useful when you want to sort of save where you are and then come back to the next day. You don't have to sort of reload in all your data, etc. It's all saved within this environment, and you can just carry on exactly from where you are. The danger of that is, and especially if you're doing that sort of more sort of tweaky code where you're doing lots of tests and trying to work out when you've got something really finicky and you're kind of trying to test something and you come out with, look, you start making all your test variables, just that I'm going to try to do it this way, so this is my way of doing it. Version 1, oh, that didn't work. Version 2, oh, that didn't work. Version 3, it was close, but it's in the wrong format. And you create a, this could just be me, but you then create this like great big long list of random variables until you finally get to the one that's kind of done the table that you want, and it's gone, yeah, that one's worked, fabulous. And then I'll build something else off on top of that and on top of that, and then you realize that actually you've created all these sort of temporary bits and pieces that actually aren't included in your script. You've just been I don't know, messing about with things, and then when you come back to rerun the entire script, it won't work. Whereas if you've got it saved in the workspace, it does. So it's kind of good practice to click on that and turn off that saving. It does mean that you have to load in your data sets each and every time, but it just means that each and every time you are working fresh and it's running through your code, and if there's any issues with your code, you're not sort of continuing where you've sort of broken something previously. As I've done it many a time when I've created a sort of a temporary test version of a function. It's worked, and I go, right, I'll now copy that into my main code, and just copied it wrong and done something weird. But yeah, anyway, the other thing that to do is the appearance as well. As I said, I've changed my font size there to be bigger. Some people like sort of dark, various different themes, etc. If you want a sort of a more dark theme or whatever, obviously choose something that makes it more comfortable for you. Personally, especially when I was doing a lot of R and I was doing a lot of Python at the same time, I always program R dark text on light background, and when I'm doing Python I do light text on dark background. But that's just me. It just helps differentiate in my head, oh, I'm doing Python now or I'm doing R now, because I'm sure as we go on you'll find out they are similar but different in many different ways. So yeah, feel free to change the appearance if you so wish. So next thing is talking about our packages. That's because Python missed the chalk, sir. Yeah, sorry, did we untick the workspace restore option? Yes, we did. Just because it's good practice. It's not a problem. It's just good practice. I mean, sometimes if you're working with a really big data set and you've done a lot of analysis and you just want to go to bed and you want to come back in the morning and have it sort of where you were, that's fine. It's just a little bit dangerous, that's all. So packages. So packages, or libraries as we call them, are like apps for your phone. Very much, I'm sure you guys have been using pandas, where you obviously have to import those. The R version of those is called a library. Exactly the same as in Python, that we do an install a library, and then when we want to use that library we can call it. So the equivalent of the equivalent of a pip install is an install package, and then when we want to call that library we do there's a library command. So we're going to be using something called the tidyverse. So again, there's two different ways we can do an installation. We can do it in code, which is install packages, tidyverse, or you can go up to tools, install packages, and it will come up with a massive long list when we start typing stuff, and then we can find the one we want and press tab and then press install. So I'm going to do it this way just because it's got the install dependencies already clicked on it, and that's probably wise. So if you go up to tools, install packages, and then find tidyverse and then press install, this is going to take a couple of minutes to chug through. So just to confirm, tools, install packages at the top, and then tidyverse. And again, very much like Python, where you do a pip install, sometimes some packages or libraries depend on other packages and libraries. So having that install dependencies just pulls in everything that all the different bits works. Doesn't work. Let's just try that again. So you've got in tools, install packages, and then you should have tidyverse, and then install. Is that working, Sigil?
Yeah, I think it's done.
Okay.
It was just telling me it's not doing anything, and then it just did it.
Then sometimes there's a bit of a lag on that. I don't know why. I guess it's got to, I don't know. I think because we're on the cloud, it's got to go through various bits and pieces. So that's installed the package, a bit like when you do a pip install, and exactly the same as we would within Python. We would then want to call, oops, not that one. We would want to call our library if we want to use it. Big difference between, so we can just do library tidyverse, and it should come up with this. Big difference between R and Python is that now we've called that library. All those commands now are just in our sort of base R environment, or in our environment now, and we can just straight use them. We don't have to sort of prefix them with like the PD or NP or whatever. We don't have to specifically call that library in order to use that command. It's just there now in our global environment. There are ways to specifically call a command, especially just to explain this bit here, is that sometimes if you're calling in lots of libraries, sometimes there's conflicts around certain verbs or names of things where they've obviously two different libraries are using the same command. So for instance, yeah, so that's exactly what Alex is saying there. So yeah, you can specifically call so if you've got two libraries, both have got a select command, and you want to specifically say, I want to use the select command from library X, Alex has told us how to do that. So when we load in this, it's giving us a warning that we've got a conflict here, that there's a stacks package which has got a filter, and there's a dplyr which has also got a filter. We are using the conflict, so by default we're using filter, and that's masking stats filter. But if we wanted to use the stats filter, then we could put stats and then two colons, and then that filter command would be the one from the stats library and not the tidyverse. So I'll just get rid of that. So the installation of the tidyverse or the library, you only need to do once, same as you would with a pip install, but each time we want to use those commands, we've got to call that library into our script, and then we can use those commands. So that's required on every session, every script. So within the so we've directly here just done installation from CRAN. So CRAN is the Comprehensive R Archive Network, contains about 19,000 packages or libraries. They're all free, they're all peer reviewed, which is a really, really important part of the CRAN repository. So any library that wants to be submitted into the CRAN archive has to go through various different hoops to make sure that it meets, has certain unit tests, that it's that it works, that has certain sort of a level of help files and vignettes and examples of how things are worked. So it has to reach quite a high standard before it will be able to be admitted onto CRAN. There are loads and loads of, obviously there's sort of 19,000 packages on there around sort of interactive graphics, dashboards, machine learning, Twitter mining, PowerPoint creation of documents and maps, etc. There's also other repositories where people haven't put stuff onto CRAN, so there's a lot of useful packages, which is more sort of development packages, which you can find on GitHub, so you can sort of download a lot of packages from GitHub. And there's also our OpenSci, which is sort of peer-reviewed, another peer-reviewed ecosystem of our packages, which has also got sort of various bits and pieces on there. One of which is a fabulous sort of fingertips package, which uses the sort of UK HSA data and a really nice GUI to pull that data through if you want to use that. Okay, so that's basically libraries and obviously installing and using libraries. We will be calling in some other libraries as we go along, and we'll have to install those. But obviously at the moment what we've done is just pulled in the tidyverse. So the tidyverse is collects a lot of the most popular R packages into one. And what's really nice about it is that they all share the same sort of underlying principles, so that they provide simple tools with a pretty consistent structure, which you can then sort of use together to sort of solve pretty complex problems, really. So during the workshops, we're going to be using a lot of tidyverse. We're going to be using ggplot2, which is a sort of fabulous plotting system. We're going to use dplyr, which is a fantastic sort of data manipulation sort of syntax to be able to do sort of filters and grouping and sort of aggregation, etc. And we're going to be using the readr package, which is basically just reads in CSVs and Excel sheets, etc. Those are all bundled up just within the tidyverse, and as I said, it's quite nice in that they all sort of follow that similar syntax, so they all play nicely, really well. So that is the very basics. What we want to do now, though, is something a little bit more exciting and actually get some data and do some stuff with it. That would be good. Just to start, so just going back a stage, because I forgot to mention it, when we first started, we had that open blank workspace, and then we created a new project. Obviously we're using the cloud, so it's just created a project within a cloud, and this is our project area. When you do it on the desktop, your project basically just creates a folder for your piece of work that you're doing. The real beauty of that is that all your work then is contained within a single folder. So if you want to put any data in there, so any sort of CSVs, Excel sheets, etc., they all go into that folder. Anything you save will go into that folder. Any output documents, etc., that you create will all go into that specific folder, which means it's just really nice at sort of keeping everything self-contained. And then there's a higher level R project file where you can save that entire project and then share that with somebody else, so that the whole kit and caboodle and all the settings and everything all goes with it, and you can package it up really nicely, which again makes it really nice sort of collaboration and sort of sharing, etc. So that's what we've done there. We've already created a project even though we didn't know it. Within our console up here, so at the moment we've got an untitled project. If you want to, you can click on that and you can change the name of our project. I didn't know that. Art training, and that will be there. And we've also got our details here. So if we were working within our our desktop, we would have a folder here with some, with whatever we've got saved in there as data. So let's just save our starting script, because it's always good to save your work as you go along. So let's call it training script. And we can now see that's saved here within our folder. So this is just a file explorer essentially on this section here. What we want to do is import some data into our folder, because we want to use those in a moment. So at the moment, obviously, if we were working on desktop, we would just save our files into the desktop. We're using the cloud, so we're going to have to import our data up into the cloud. So I believe yesterday or there on the Slack, there was a zip file with some data sets in there. Hopefully you've had an opportunity to unzip it. If not, you can do so now. And also, put them somewhere where you can find them. So I believe there's, I'm trying to remember, I think there's 5 files. And what we want to do is upload them so that we can put them into our virtual folder. So we want to click on the upload and then choose file. It's taking forever. I've very sillily put mine on the desktop. And where are we? We've got beds data, capacity AE, and then these TB cases, TB new cases. Yeah, I'll go through that in just a second. So beds data open, and then okay. Upload is here on the middle right up here. Yeah, sorry. I don't know if you've clicked on something else. So it should default onto the Files tab. There we go. So you have got various other tabs, which I'll go through in a minute. But there's Files, Upload, Choose File. And the ones that we want. Unfortunately, I don't think it lets you. There is an option, it does say about uploading a zip file. So I've not tried that actually. I don't know if you can just upload the zip file, and it does say it will automatically expand it after upload. So you might be able to just upload the entire zip file. Don't think you can do multiples. No, you can't. So there's 6 files I think we want to upload. Zip works, look at that. Fabulous. So yeah, if you want to be one of the cool kids, you can just upload the zip file in one go. What am I on? Cases and table. So this is, as I said, just the equivalent of putting them into a folder that we can get to. Unfortunately, we have to upload them first just to make them available. If we were using desktop, we would just be copying and pasting these. 5. Yes, that's right. Yep, that's correct. Yeah, beds data, capacity AE, cases, new table, and pop. Sorry, my mistake. I think I've got an extra one for some unknown reason. So you should have 5 CSVs. So this puts everything into that nice project folder. Which also means that you can then switch between, if you're working on different projects or you just want to load in you know, a piece of analysis to do with a specific project, you can just load in that project. So it's a really, really good way of staying organized and keeping everything all in one place to do with a specific piece of work, which is really, really nice. That sort of built in as default. Otherwise, everything ends up in your, I don't know, R folder, and you've just got a gazillion things of very, very messy, and it's then very, very hard to keep up with version control and various bits and pieces there. So yeah, so our projects definitely make it easier to sort of organize your files and your workflow. You can sort of switch between projects, makes it easier, and also means then if I want to share my project with somebody else, or you know, get somebody else to do this piece of work, hand it off to somebody else, and I've written this thing, you can then just say it's all in this folder, and they can just open up the project file and everything they need will just be there, rather than sending somebody, you know, 5 billion different links, etc. And you know, you'd pull this in from here and that in from there, and etc. So it's definitely recommended for sort of all tasks, big or small, to sort of put your stuff into nice projects. So if we were using if you want to create a new project, if we were sort of starting off from there, is it possible to move files between projects? Yeah, absolutely. It's, yeah, so as soon as you've put something in, so a project basically sets that as your default area. So you can move something into a different project, you can copy it or move it across. You can explicitly tell R to save things or load things, and you can give it a sort of a file path and it will follow that file path. By putting something in a project, it just means you don't have to do that. It automatically defaults the whole file path to where you've created a project, which again just makes things really, really easier. And it means if you lift and shift the entire project, you then don't have to change all of your file paths to your stuff. It will still sit within that project. So if you lift and shift the entire project, I will still know that this is a project and it's here. So again, that just makes things a lot easier if you know, things have suddenly changed, etc. So if we wanted to create a new project, we can, where are we? No, we're not on you. Sorry, wrong area. Where am I going? Yeah. No, what am I doing? It's yeah. Oh, it's different on our studio, isn't it? Cloud. Where is it here? I'll go back to that in a minute. Right. Anyway. So definitely use projects for your work. We are now at past. So has everybody got their 5 bits of data in there? Hopefully you've got your 5 sheets in there. If not, give us a shout. It's past now. Let's have a quick 5-minute break. Just so I can go and grab some more coffee before we get on to the next bit. So yeah, let's have a 5-minute break and sort of come back at whatever that is, 25 to 11. And I'm going to leave it recording. If anybody's got anything desperate to shout at, pop it in the chat and I'll come back in a couple of minutes and have a look. But hopefully you've all pretty much got what I've got on the screen. If you haven't, pop it in the chat now and I'll come back to you in 2 minutes after I've grabbed some coffee. Okay, it's 25 to. I am hoping you're all back. Hands up if you're not back. That doesn't really work, does it? I'll just carry on. So we are now going to import data because obviously that makes things much more fun when we've got some data. So there are various different ways we can import data. As I said, we can link up directly to SQL. We can download zip files. We can link directly to sort of the URLs and download data from that. There's a fabulous where are we? There is a fabulous package which allows you to sort of copy and paste data, so you can have a data table in a what's the word, PDF, and you can sort of copy over it and highlight it and then paste it into R, and then R will convert it into a data table. It also does that for Word as well, which is properly clever. But we're gonna cover some real basics and just load in some basic CSVs. But yeah, there are some really amazing ways to import data in various different ways. So we would like to import the capacity AE CSV file. So we could write that code from scratch, or there is a little bit of an import wizard which we can use to help us. And I'm all for being lazy and getting wizards to do work for us. So up on the top right hand here, where we've got our various tabs, I'll go through some of what these bits do further on as we go along. But basically in our environment, we've got one here that says import dataset. So if we click on that and we want to import a data set from text using readr. So it's the second option down. So just to confirm again, environment, import data set, second option down, readr. And it's telling me I need an updated package. Do I want to install it now? Yes, I would love to. I'm assuming you've got all the same, but that installs very quickly and just does once. And then it should bring up a text box, oh, sorry, a new window such as this. We can then click on our browse button and look for our capacity AE CSV, which we should have here, and open. And it will give us a very quick preview of what our data looks like, just to make sure it's right. What's also quite nice is that it's given us a bit of code preview. So as we go through, what we could do is every time we run our script or we try to do this bit of project, we could go into the import wizard, do our bits and pieces, and then we'd have that data to work with. However, that's really dull. We're all about scripting. What we want to do is write some script. So what we've got here, oh, got somebody in the waiting room. What we've got here is a code preview. For those who've just joined, I'll whiz through this again in just a second, just to make sure everybody's up to speed. We've got a code preview, so we can just do a copy of that. So just Control-C or right click and copy. And then if we cancel, and then we can just paste that into our script, and that will do that. So for those who just caught up, let's just come in. On our environment, we want to go to import dataset, from text, read R, and then browse, find our capacity AE, and open. It will come up with a preview. We could just press import there, no, just import the data set, but we don't want to do that. We want to copy the code, which is either Control-C, or we can do a right click and copy, cancel that, and then paste it into our code. and then we can just highlight over that and run. So that will do a couple of things for us. Has everybody got it to do that? Has anybody got anything weird or different? Anybody not got that? All good. Excellent. Excellent. So what it's done is in a new tab up here in our scripting language, we've got a copy of the data. So we're just having a look at it. You can click up on the top and you can just do a very quick sort of the data, which is quite useful just to getting a little bit of an eyeball of what we've got, see if we've got any issues with it. And we can just close that tab and it will get rid of that, or we can go back to our training script. So just running through the script, what it's done, it's loaded in the readr library. It's done a read CSV of that CSV and it's put it into this object called capacity AE, and then we've viewed our capacity AE. Up here in our environment, we also now have some data. So it's telling us we've got a data object called capacity AE, which is 68 observations of 5 variables. And there's various different things we can do. So one of them, we can run a view command. So if we just want to run that command and run, again, that will put it up in this viewer and we can have a look at our data, and that's just literally seeing it. You can do that same thing by just double clicking on the data on the top right hand side, and that just creates a view up here, and that also lets us have a look at what's at our data. We can also click on the little blue arrow to the side of our data, and it will give us some information about our data. So our capacity AE is the name of our data set, and then we've got a $sign, and then we've got these, which are our column names. So if we look at our data, we see we've got, these are our column names, which is the equivalent of capacity AE $sign site. We'll reference that section there. It's telling us this is numeric. We've got some attendance data here, which is also numeric. We've got a staff increase, which is a true false, and that's come through as a logical data type. And then we've got some other details here around D cubicles and D weight. Has everybody got that? And then we can close that up again. There are some quite nice, so yeah, let's just load in the data to capacity AE. And in that data in that tab. And also double click on environment. What's the rules between library lowercase and view uppercase? Yeah, things aren't always consistent. So because lots of different people write lots of different packages, not everybody sticks to the same naming conventions. So as we can see, we've got a read underscore CSV as a function here. However, for whatever reason, the person who created the view function decided it needed to start with a capital V. Don't quite understand why, but that's what they've done, which is very naughty. We also have some commands which are separated with dots, sort of full stops, and we also have some crazy commands which are in is it camel case, where you have capitals in the middle of words and things, and all gets really, really tricky. Oh, look at that. Go away. Oh, sugar. I'm supposed to be somewhere. Why have I? No, sorry, just realised I was supposed to be at a meeting. I better say I can't make it. Sorry about this. Sorry about this. So another way that you can also get to your view of a small works anyway. That is very strange. Don't know why that is. Let me just, I don't know, somebody obviously had me booked in for a meeting. I haven't said yes, but sorry about this. So another way that you can also do a view is that you can press Control and then click on an object name, and that will also bring up, so you can press Control and capacity AE, and that will also bring up the view of your data, which is really, really nice, especially when you've got quite a long piece of script and you want to know where you are with where your data is. You can so hold Control and click on data. Use command if you're on a Mac. Object. I will share my code that I'm doing now for you as at some point. Where's that doing that? All right. Think I've. How do you do the right click to view? No, it's not right click, hold Control and then click on top of it. Let me just move that out of the way. So you can hold Control and then click on capacity AE and all that. Right. Okie dokie. So we've got some data in. We can do some really, really simple things to do some exploratory data analysis just to work out what we've got here. I can't spell. I definitely cannot spell today. So if we run a summary function on our data, let's just, oh, sorry, I forgot to say, you can also move the window sizes and mess about with those if you want. So it will just tell us some basic data about our data. So it will just do very simple min, max, median, quartiles. If you've got any NAs, it will tell you how many NAs you've got in your data as well, which is just really, really useful to try to understand what your data looks like. Oh, excuse me. Right. So we have got some data in. So let's do something with our lovely data. So done all that, done all that, done all that, done all that. Okay, so we've got some data. Let's do something with it and see if we can understand what our data is and hopefully try to answer a bit of a question and do this amazing thing called some analysis. So what we're going to do, we're going to plot some of this data to try to answer ourselves a question. So if this decides to wake up, there we go, right. So we are going to do some plotting to try to answer the question. So we're going to have a go at ggplot2. So this does cover a lot of the stuff which is in the fabulous book R for Data Science. There will be a link to lots of these books and resources at the end. We'll sort of show you where all those are. They are absolutely fabulous. You can buy a paper copy if you so wish, or there are free and open source available book down versions or interactive books available online. So all the training resources and all of these books that we'll be using or we've taken bits from are all absolutely freely available. So ggplot is one of several plotting systems within R, a bit like I suppose in Python you've got Seaborn and Matplotlib. So ggplot is the equivalent of those. It's the sort of the one that is mainly used. There are other systems are available and are used for sort of different things. So Plotly is fantastic for making, well, just plots really. However, and I don't know if you've used it, I think you possibly might have done a little bit of Plotly when we're doing sort of forecasting and things like that. So Plotly you can use then to sort of make interactive plots with sort of hover overs and drill downs and sort of clever things. And I'll touch on some of that in our next session. So why is it popular? All of those reasons. ggplot works in a similar way to Matplotlib, as far as I remember, my Matplotlib site, in that you sort of build up your basic plot and then you just add layers and layers and layers to it. So if you want to sort of change anything on it, you can adjust those bits and pieces. There are some sort of fabulous themes available. BBC use ggplot2 to use their to do a lot of their graphics. So ggplot2 is an integral part of the tidyverse. So we've already loaded in the tidyverse in our script, so we don't need to do that. That's absolutely fine. So our first project we're going to have a look at, we're going to look at a perennial challenge, not a perinatal challenge, as I often say, for the NHS. Pressures in the A&E. I mean, I don't know who wrote this, but is that a thing? Anyway, we've got lots of demand and we've got some capacity and we've got some ambulances and we've got a little man here. I don't know what he's doing. Anyway, demand and capacity problems. So the data set that we've loaded is our capacity AE, and it shows the changes in the capacity of A&E departments between 2017 and 2018. So we've got an object called capacity AE, and that's our data frame, or what we call a data frame. What is a data frame? So a data frame is well, a frame of data where we try to look at it stores tabular data, yada yada yada. So in tidy data, each variable forms a column and each observation forms a row, and each cell is a single measurement. Probably either later today or possibly early part of next session, we will look at how we can look at long data and wide data and sort of convert them from one way to another. But yeah, you've met Hadley. Wow, that is properly. Did he have his sorry, somebody's saying they've met Hadley Wickham. Did he have his trademark bow tie on? I hope so. Yeah, he did have his bow tie on. Fabulous. He's very, very well known, very, very clever chap. I will go on to some resources at the end, but one of those is something called Tidy Tuesday, where basically they just get really, really clever people in the world of R, give them a completely random data set and then say, away you go, what can you do with it? And there's nothing better than seeing like Hadley Wickham, who pretty much built the tidyverse, just writing spelling mistakes and doing like the really basic, not putting the commas in the right places, all those really basic errors that throw you every time. And it's like, Hadley's doing that too. And it just kind of almost makes you feel human. Anyway, so we'll be using something called a data frame. Technically, what we will see is something called a tibble, but for what we are for all we are concerned about, we're basically working in data frames. I mean, I guess you guys have used Python, so you're aware of the difference potentially between you get sort of arrays, and you get series, and you get, I can't remember, I can't remember what the pandas called them, data tables. I'm trying to remember now. Or was it data frames? So you've got all these different potential data types of things, but what we're going to be using is you pretty much bog standard data frame, yeah, that's what we're going to be using for here. We are going to be using a few vectors later, but I'll explain that when we get to them. So viewing the data frame, we've done all this already. We've had a look at it. What we want to do, oh sorry, the other thing I didn't mention, which was quite a nice little feature, is that when you have got your data frame on screen, you can click on this little button here, which spits it out into another window. It's a little bit slower on the cloud for some reason. In fact, mine's going really slow. But it puts it out onto another window. And that's really nice, especially if you're sort of working with data and you want to chuck it off onto another screen so that you can do stuff and look over to it and try to remember what your column names are, etc. And also in that view, you can do some really sort of basic filters as well, just so if you want to check what your data looks like. Totally gone off on a tangent as per normal, Simon. So we've had a look at our data frame. We can also just run our data frame, and it will print out ahead of it into the console. So let's just run. So instead of doing a capacity, a summary of capacity AE, if we just simply write without spelling mistakes. Oh, my computer's gone super laggy. Capacity AE. And again, this has got really nice autofill for you, so you can just press return or tab on what you want, and that will autofill. And it also obviously does that for commands. It also does it for data as you go on and create objects, which is really handy. So if we just simply run that, so I just press Control Enter, or you can run that. It will then just give us a view. It will tell us that we've got a tibble, which is 68 times 5. So that's our 68 observations of 5 variables. And it will just show us the top 10, as it were, and tell us what they are. And it will also tell us what our data types are, which is quite useful. And it will tell us that we've also got 58 more rows. And it will just give a little bit of information that if we wanted to see more within the console here, that we could do a print n equals whatever to see more of those rows if we so wished, but we don't want to do that. So do we understand the variable names and what do they mean? No, I think is the short answer to that. So let's go through those. So the site, that just gives an ID number for the site. So we've got however many it is, 68 individual sites. We've got an attendance number in 2018. So how many attendances they had in 2018. Then we've got a logical, which is a true or false. Did the staff numbers increase between 2017 and 18? So if there was a staff increase, we've got a true. And obviously if there wasn't a staff increase, we've got a false. And then we've got the difference in average between the 2017 and 2018, A, for the numbers of cubicles available, and also the numbers of waits. Sorry, the time of waiting. So we've got an average wait. So what we're trying to see is, by increasing the staff, has that had an effect on the waiting times in effect? And is there a relationship between the numbers of attendances, the numbers of cubicles and waits, etc.? Which we are going to do a nice little bit of visualization to try to answer those questions. So yeah, we're going to do a nice bit of visualization, and Mr. Turkey, or Tuki, I don't know how to pronounce that, it's just telling us how great graphs are. So our question is a change in the number of cubicles available in A&E associated with a change of length in attendance? So let's start. So we're going to do a plot, and what we want to do is plot our numbers of cubicles against our length of attendance. So we start off with a GG plot, which is over to us now. Let's just, will that play nicely there? No, it's going to disappear as soon as I do that, isn't it? So let's get plotting GG plot. And the first thing we want to do is tell it what data we want to plot. And our data we want to plot is our capacity AE. So hopefully that's relatively straightforward. So our data that we want to plot is all in our capacity AE object. Next thing we want to do is add some layers. So we add layers with the plus sign. So this is where we start getting a little bit different from our friend Python, but also quite similar. So in the same way, let's just do something completely different over here a minute. So in the same way as Python would do, you kind of, if you want your command to go over to the next line, you need to end with your comma or your plus, or you need to keep an open bracket so it knows to go to the next line. For a GG plot, we use the plus symbol to say that we want an extra layer onto our data, onto our plot. In some of the stuff we're doing later, we'll be using pipes and various different things. So what I want to do is give it some X and Y coordinates that we are going to go through. So we want to use a geom point, which basically tells us that we want to do a scatter graph. And then let's go back to that. Let you copy it out there. And then there are certain things that we want to put in our geom point, and those are called the aesthetics. The main two aesthetics that we need to know for our point are its X and Y coordinates. We can also feed in, and we will do later on, things like size of the point, color of the point, groupings of points, etc. But for absolutely bog standard scatter graph, we just need an X coordinate and a Y coordinate. And so we do an AES and then another set of brackets, and then our X is our D cubicles and our Y is our D weight. So I am going to cheat and paste that in. So, oh no, that's not worked at all, has it? Let's go. So, bit of a difference from Python in that R doesn't care about indents. R likes pretty code, but isn't completely and utterly indent crazy. So it has automatically given me an indent. Just run that, and we should come up with something like that. So it has given me an indent automatically. However, if I really wanted to be ugly with my code, I can do that and it will still work. And I can do that and it will still work. And if I wanted to be really evil, I could do that and it will still work. But we're not evil here, so we're not going to do that. So we can do a return after our plus, and we can also do a return after our comma here to make our data, our code, nice and readable. And I'm sure you would be aware that if always got to leave your sort of trailing commas to go on to the next stage. So in this code, this will work. However, if I remove that one there and had my comma at the front here, it's not going to work. Actually, yes, it will do, because I've still got the this will work because it's still in the brackets. But anyway, if it wasn't in the brackets and I was splitting something out, that isn't going to work very nicely. So generally don't do that. RStudio has got some pretty good syntax errors there, and it's telling me that here I'm expecting a comma after the expression, which it exactly is. So there we go. Has everybody got a scattery plot that is looking like we've got a line of something possibly going on? Yep. Fabulous. Cool. Right. So that was my cool. So we've got a very basic plot of some description, and it looks like we've sort of got some sort of shifty sort of line, but what does that mean? Who knows? So let's explore it a little bit further. So there's lots of choices about the chart. And we can also do sort of various things about it. And oh my goodness me, pie charts. So choices around things like, obviously at the moment we're talking about the aesthetics. We've done things like changing all we've done is an X and Y coordinates, and everything out has just gone to defaults. Obviously we can change the shape of our data. We can represent what shape. We can add different visual aesthetics, so we can change the size, the color, the position, obviously the X and Y axis, those are aesthetics. Change the color. So so at the moment, all the size, shape, color, all of that is completely by default. Just to say that functions, so things like the ggplot, the ggpoint, AES are functions, and we've already used a couple of functions in our code already. We've done a read CSV function. So if we go back to our code, which is somewhere, we can see that we've got these functions. We've got a view, and that's got a thing. So all functions are basically called by a function name and then brackets and then whatever feeds into that function. So we've got a ggplot here, and then we've got brackets, and then it's asking for us data. We've got a GOnPoint function, and again it's asking for stuff to go into brackets and go through there. We've got our read CSV function here. So all functions use brackets, so it's a function name and then brackets, which is worth knowing. So running a function does something. Functions are given 0 or more inputs. So sometimes functions just have, a load of stuff defaulted. I'm assuming you've done functional programming within your Python and built your own functions, and yeah, you must have done. So hopefully you understand what obviously those are. And tomorrow, or not tomorrow, next session we'll do some sort of how to do sort of functional programming, etc., because we can do all that. And you can also use classes within although I don't think I'm going to have time to be able to show you that. So within functions, you can explicitly name arguments. So we've done ggplot data equals capacity AE, just to make it really clear, but it's not necessary. You can use defaults. It will sort of go through the order of your data and will pull out what you've put into the data. Personally, I find it really helpful, especially for future Simon, because we've talked about him and he's got major problems, is to actually explicitly tell your put in there what your data is. Same with our X and Y coordinates. Potentially, if you wanted to, you could do Y first and then X, which could potentially be confusing. So yeah, don't do that, but you potentially could. However, we could also say that our X and Y could default to their default values. So what we could do is ggplot capacity AE, and then G on point, it would assume this is X and that is Y. Just because that's the order that X goes first and Y goes seconds. So it's not always necessary to name arguments. I just personally find it really good practice, especially because I know what future assignments like. So sometimes something like X and Y, that's quite easy to work out what those are. If there were additional things going into that function, it becomes really, really tricky when you're trying to unpick what you've done about what are you feeding into that thing. So I find it much easier to explicitly say what I'm putting in there. So geoms. Geoms describe the plots in terms of the geoms used. So there are lots and lots and lots and lots of different types of geoms. We're going to explore a few others in a bit, but there are geoms for absolutely every type of plot you can possibly think of. But obviously, a couple of basics ones here. We've got lines and box plots and histograms and stuff. And what's really nice about them is that they all work off the data. And so things like a box plot, you just feed in the data and it will work out all the stuff for you. Things like histograms, I think we'll do some of them a bit later, but you can just sort of feed in the data and then sort of tell it how to bin your data for your histogram. It will do that for you. Whereas if you've ever tried to do like histograms and box plots in Excel, it's an absolute nightmare. So at the moment, we've got we've layered some geoms. So what we want to do now is add another geom. So we've got our nice-ish, well, I say nicest, it's really ugly plot. We've got our really ugly plot, but what would be really nice to do is if we can add in some sort of smoothing line or trend line to help start trying to answer that question. And can we actually sort of see a trend that is going on there? So let's add in a trend line. So again, really, really simple to add in there, and it will do all the hard work for us. So we want to add in a geom smooth. So we've already got our geom plot there. Now we've got our geom point, and then we want to add in a smoothing line. So let's go back to my code here. I'm going to do it separately, just so I've got add smoothing line plus geom smooth, and then copy those again because I want that. And done. Has everybody got a wibbly line on their data? So what that has done is added in who hasn't collect? So let's have a look, work out what we've got. So same as before, we need another plus at the end of our geom point, and then we want a geom smooth, and then exactly the same. Anybody else got problems, Colette? Have you got that fixed? You haven't got it either. Yeah, didn't put the plus in. So just run it through it again. So we've got our original plot, where we've got our do there. Then we want to do a plus at the end of it because we're adding another layer. And then we want our geom smooth. And then we want our AES and then more brackets, X equals D cubicles, Y equals D weight. If you've got an error message, paste it in the chat. Yes, we can, Evelyn, and we will come to that in a minute. Quite often, it's best to sort of show you longhand, and then we can show you shorthand. But yes, we will. We will. But it also means that potentially we can unexpected symbol in D weight. Is that the full error message? Have you got another? Should have two closing brackets because we've opened up two. Is that working now, Phil? Anybody else? It's very hard. Probably easier to shout if you can come off mute.
No, it's not working. I'll paste my code in the chat.
Yeah, okay. That's weird.
Bizarrely enough, it's now worked. That is very weird. So it wouldn't run when I highlighted it, but doing Control Enter has made it work.
Did you highlight the whole lot of it? Did you?
Yeah, it's working now.
Okay. I mean, quite often I go and do things like that and try to run it, which is very, very poor. Right. So hopefully everybody's got a wibbly line. Just to go through a couple of little nice bits about, again, sort of our studio, what it tries to do is when you're next to a bracket, we'll try to highlight the matching bracket, which is really nice, especially when you get into those lovely nested commands of doom. So again, if I'm next to that one, it will tell me but the matching bracket for this one here is that one there. There is an option in the global options that you can set your brackets to rainbow brackets, so it color codes them. And so it tries to color code them across, and then you can sort of try to match by color again, which is quite nice. I think Excel does that, which is quite a nice little feature. I'm not going to do it here because apparently it doesn't share very well on through Zoom and stuff. I've had feedback for, but I'll usually do that. It also makes your code super pretty, which is quite nice. So there's that. So what we've done now is automatically fitted using a LOES model, which is least ordinary estimated sum of squares off the top of my head. I'm trying to remember now. Something like that. So basically it's quite a funky smoothing line where it uses a sort of formula a bit similar to a k-means, and it kind of sees what's near it and then tries to create a line based on what's near it. So it's quite a good fitting liner. However, it can massively overfit to outliers and do some weird things, but it kind of looks at what's close to it and then tries to make a wibbly line based on that. However, we can also fit different types of lines to it, which I think we are going to do. So yeah, we've come out with that. If we want to, we can add a linear line to it, which will just be a bog standard linear regression. So let's add LM smoothing line. So copy your data again. I'm going to copy your code again, sorry. And basically, we're just going to feed another feature into our Geom Smooth. We want, so this is where it gets a little bit complicated when you're first starting out. So the AES is the aesthetics for your actual dots and your charts or your line or whatever. So anything that we put within this AES subset of brackets will affect all the dots and bits and bobs and pieces. Our actual smoothing line are not to do with these dots and bits. They're sort of calculated separately. So we want to create a separate, we want to tell it to do something different than what we do. So we're going to change the model that we're using. So in between the two ending brackets, we want to add in a method equals LM and in speech marks. And I'm going to make it pretty by moving that here. So let's change that to smoothing line. So now that will give us a linear trend line rather than a smooth trend line. Because R is super cool at stats, we can also do a, what we got? E cubicles to the, wait, oops. I can't spell. What's it called? Capacity. And we can create ourselves a very quick linear model of our data. So sorry, that's not included up in there. And that will pull through our coefficients and our statistical significance and our residuals and all of our lovely stats on our linear model, if you are so inclined about doing. The main one that we're interested in is that our three little asterisks is here, which shows us there is something significant going on between here and here. Not going to explain all linear modeling stuff for you now. So what is happening? What is happening here? So, sorry. That is the tilde sign, which is shift hash on a normal keyboard next to your return key. Sorry, I should have. That is a bit of a weird one that we use. Shift, so that's called a tilde. And yeah, shift hash. Well, it is on my keyboard. You might have some weird Mac keyboard or something. I don't know. Hopefully that comes through. Cool. So we've got a couple here which appear to be not like the others, a bit of outlier. So let's look at our hypothesis. So we've got two sites that have seen staffing increases. So what we want to do what we can do to our graph is if we map the color based on the staff increase, we're able to highlight which of those sites within our data set here has seen an increase. So we want to go back to add color to graph. So let's load in, let's copy our data in again. So if you're doing this all on one, that's absolutely fine. It's not a problem. So we want to now add a, we want to color our dots in based on our staff increase. So we just remember our data again. If we have a look at it, we've got a staff increase, which is basically a true or a false. So we want to color all our true ones in one color and all our falses in another. So we've got our G on point here, and we've already told it its X and Y coordinates. But now we want to give it another aesthetic to say we want to change the color. So literally we can do a comma and then color equals staff increase. So now, depending on whether it's a true or a false, it will color them in by default one color or another color. So this sits within the AES because we are changing a feature of the dots. If we wanted to color them all something, we could color them, but our color would be outside of the aesthetics because we're just doing something across the board. If we wanted to change the shape of them globally, then we would do that outside the aesthetics. If we wanted to do it based on something, then we include it within the aesthetics. We'll have a play with that in a minute. So now if I've added color to my graph, peel, we can see, hopefully relatively clearly, that our sites which have had an increase, which is this one, this one, this one, and this one, on the whole, have seen a reduction in their weights. But obviously these ones are also still a little bit high. But obviously I didn't know what they were. But you know, we don't know what else has been going on with those. But on the whole, we do appear to see a difference. If we wanted to, we could let's just have a mess about a little bit, and let's have a little bit of a free form. So what we could do, instead of color, we could change that to, is it, I just remember what it is. It's going to size, I try to remember. We can blop and we can do a size based on this thing. Ours telling me off here the warning message that is just a warning that using size for a discrete variable is not advised. Yeah, it's probably right because that's really, really ugly. If we wanted to, we could change our, I don't know, our size based on our numbers of cubicles. And if we wanted to, let's put it outside and we could do color, oops, equals red. So my size is based on my D cubicles now. So as what I'm expecting to see as we move to the right, the dots should get bigger. I've put my color outside of the aesthetics and told it to be red, which should just then make all of my dots red globally. So let's have a look at what that looks like. Ghastly, but hopefully you get the point. So everything there is hopefully changeable. I mean, you can potentially add in and change it to sort of the shape, the whatever. You can have tweak with those to do various different things. I don't know, it's a very recent thing that our studio has done recently to tell you what color that is and what red is, in case you didn't know. You can also put in hash codes for hex colors, which is also really, really useful if you want to stick to the NHS color scheme and very specifically use those. We will come to that in a minute. So we've done that. So we've done size. So again, if we wanted to make our size global, then we would stick it outside. If we want it based on something, we can make it based on a feature. What else have we got? So to answer Evelyn's question, so to avoid duplication, because we're all really lazy and we don't like duplicating our data, our coding, because we've got poorly fingers and we don't want to have to type in x equals y equals again and again and again. We can put our AS within our ggplot. So let's take it out of there and put it in our ggplot here. So we've moved it there, and then we can also now remove it from here. If we want to convert back to a lowest model and not even put anything into our geom smooth, it would literally be like that. And likewise, if we didn't want to specify our color, it would be blank there as well. So now running that, oops, using size aesthetic was depreciated. Oh dear. So it has worked, it's just telling me off. I should be using line width. Oh, okay, that makes sense. Because I'm feeding the same thing, I'm feeding this size cubicles through to my geom smooth. My geom smooth doesn't like size, it doesn't make sense. So it's giving me a bit of a warning, but that's fine. I'll just remove my size. There we go. It will stop whinging at me now. So what you can do is just feed it in once, and then just those bits will just feed into your point and your smooth. So if I did want to change my color, my size equals d cubicles. If I spelt that completely strangely, I could feed that in there. Oh, no, I can't spell. Oh no, it won't feed that through. No, forget that. No, I'd have to pull the whole lot through. Ooh, don't do that. Okay. So yeah, if I wanted to be lazy and not feed it into every single part of the plot, I can feed that through. What that does mean, if you do it like this method, then you can obviously pull through different layers and you can have your smoothing based on different XY coordinates if you so wish. Definitely recommend not plotting like two different charts on two different scales onto one plot. It is possible, but it's really hard. And the reason it's really hard is because it's utterly nonsense and it's really bad visualization practice. Never ever plot two things with separate scales on the same plot. It's really bad visualization practice. The amount of horrible bar charts with floating line charts over the top of them on a different scale to try to show some sort of correlation between things just makes me sad. So don't do that. It's really bad practice. If you want to do a correlation analysis, there are statistical ways of doing correlation analysis. Plotting two things on top of each other and going, they vaguely go up and down a bit, is not how you do correlation analysis. So please don't do that. So let's do some magic. So what is a really, really nice other little functions that we can do is small multiples. So we are all going to do some facet magic. Let's just get rid of our geom smooth for now. So just going back to here, back to our basic plot. What we want to do is add in something called a facet wrap. So back to the basics, and then we want to add in facet wrap. And then we want to use our tilde button, which is our shift and hash staff increase. And then hopefully run that. And what that will do is basically tell it that we want one set of data, but we want to create a separate chart based on a separate variable. So in this instance, we've got staff increase, which has basically just got a true and a false. So now we've got a chart for our trues and we've got a chart for our falses. Where this becomes really powerful, probably in sort of your more day-to-day work, is if you've got several teams or several regions or systems or whatever level you're working at, and you want to use that same data set but facet it across the teams, across the regions, across the treatment functions or whatever. So you just create one data set, one plot, and then you can create all the subplots all in one go, which is super, super fantastic. So this example is just showing obviously just the true and a false, but if we have extra additional things within that data set, you know, we could build up absolutely huge amounts of lovely facets across all the different things. And it means that, you know, we can also avoid those horrible spaghetti charts where we just plot all of the teams on one plot and then we can see them go bleh. By using facets, you know, it's definitely, you know, we're not printing these things out, we're not killing trees anymore. Let's have one plot per thing, and then you can actually do a proper side-by-side comparison rather than trying to unravel spaghetti. Not a fan of spaghetti in plotting. If we want to, we can obviously add various, you know, all of these things are changeable. So we can add our non-col equals 1. And that will put them up above each other if we so wish. And obviously we can specify rows and whatever. I mean, if we wanted to, and I wouldn't recommend it. So we've got, what have we got? We've got a site, haven't we? Yeah. I mean, we could do a plot per site, which as far as I can imagine, it's going to give us 68 plots with 1 dot on it. So obviously don't do that because that would be really, really silly. It's obviously going to take a little while to render, but it will come through. Another thing we can do is we can click on the little zoom button here, which will ping out our zoom, our plot, and we can manipulate that a little bit. But anyway, obviously that's a complete nonsense because obviously we haven't got decent data in there, but hopefully just sort of shows that you can create huge amounts of charts across various different things really, really nicely, really, really easily. There are export options here just within our studio if we wish to, so we can just save that as an image or PDF or copy it to clipboard. We've got a little broom here if we want to clean out all of our plots. If for whatever reason a plot is having problems rendering, there's a cancel button here. And you can also flick through your plots. So does it, let's have a look. Let's go back to, so somebody's asking, how do you make the geom smooth work? So what do we want? We want it on staff increase instead. And I forgot my plus there. So those are definitely different lines. They're not, because that one's given it massively huge confidence levels because we've got such sparse data. And those are, yeah. It's not right. It's scaled really. It's scaled really weirdly because that's obviously it's expanded to show the confidence levels for this one. Obviously, at the moment we're sharing a y-axis, but we can tell it that we don't want it to do that by okay. Well, let's. Very good thing. So I can't remember all of the functions for every single function. So I think we're going to come to it in our next lesson, but we're going to do it now. Help is always really, really useful thing to be able to find out. There is a help button here where you can do a search and you can find answers to different things. I find a really nice thing is that you can just click on a function and then press F1, and it will now tell me how to all the functions and usage of the facet wrap. So it tells me these are all the here. Sorry, here where. So yeah, just click on something and then press F1. So you just click. So if I want it on ggplot, I would just hover, just click my cursor onto ggplot. If I want it on facet wrap, just click on facet wrap and then press F1. So now it's telling me, yep, just getting back to that. You can also type into the console question mark and the name of your function, and that will also come up here. So it'll give me a bunch of options, and what I want to do, I want to scales. That's it. So I want to have them on 3 scales. So scales equals 3. So if I run that now, it's put them on different scales because this one is, and then you can see a lot better what's going on there. You can set them as a 3x scale, 3y scale, etc. So is your geom smooth working now? Hopefully that makes a bit more sense and you can see what's going on. But also if I wanted somebody to put it in there, another way to get help is to just do help facet wrap. And that will also bring up the answer. And as I was saying, as part of the getting approved to go onto the CRAN repository is that you have all of these. What's also really, really nice is that R has some built-in data sets, as in just some standard data sets. They're not massive, they're just some little data sets built into R, which means each of these functions, then they can give you a reproducible example. So literally I can run this and I can do find my ggplot there, and I can just run that, and I can copy an example out of the help, which is really, really nice. Nice little feature that you can have a reproducible example of, right, okay, this is it, and then you can kind of unpick it and hopefully get to where you were, which is really nice. And obviously this is just giving you a couple of different examples at different levels, and yeah, so if you want to change how the labels are printed or changing the order that the panels appear, etc, etc, etc. So literally this has got an example of exactly what we had here about how do we set our scales to be free. There we go. So again, the help functions within R are really, really useful. The other thing I find much better than Python is actually all the error messages. So I quite often find that the warning messages and the error messages are actually quite useful. And if you're ever stuck, I definitely recommend just reading out the error message out loud to yourself, because a lot of the time it will actually answer your question for you, which is fabulous. So we'll do a little bit more and then we will do some other bits and pieces. So let's just do some very quick. Let's go back to our version here. Make it pretty. So I really don't like the standard output. So let's just go back to what that one looks like. There we go. So we've got that. I don't like grey backgrounds and I don't like the grids. So there are ways, and there's lots of variables that we can just change the theme. So let's just do theme minimal is my favorite, and I'm not going to add anything else to it. I'm just going to add on that plus theme minimal to the end, and it will just get rid of the black and change a few bits and pieces. If we want to, there are some. So if you start typing in theme and then underscore, oops, it will come up with a few other options. So theme dark, what does that look like? Ghastly. But there are a bunch of themes. There are libraries of themes, so you can download like the I think the BBC have got their theme available that you can just pop it out. Financial Times has got one. There is an NHSR. There is an NHSR theme which converts everything over to use NHS colour schemes as per standard, which you can get on the NHSR GitHub. So yeah, but basically you can also set up your theme so that you can set up a theme for your team. So if you want to use specific corporate colors, etc., certain fonts, etc., you can change that. Much as you can with Seaborn and Matplotlib, everything on the chart is up for grabs about what you can change. So obviously you can change labels, you can change fonts, you can change. At the moment, it's gone, you know, gaps of 20. If I want that to be gaps of 10, I can change that. If I want it to be gaps of 4.76, I can change that, etc. In everything within that chart plot is up for grabs. So let's just do some other quick plots. Let's do a histogram. I can't spell histogram. So we want to do a ggplot. Our data equals capacity, I can't spell, capacity AE, and then we're going to do a geom histogram, and you need an AES. Because we're just doing a histogram, we only need one variable. So let's just have a look at our D weights. And we can run that. And it will give us a very quick and dirty histogram. And it's told us as standard, we've given it, it's given it, where are we? 30 bins. If we want to, we can change our bin width. And again, just on the fly, it will change our bins, which is quite nice. So we can do a bar plot. I should probably have copied that from up there, shouldn't I? Data equals capacity AE plus GR yes. What have I done wrong there then? Ah, so that should be an equal sign, isn't it? Yeah. So that gives us an ugly bar plot. What would be much nicer is if we copy that. And let's make an ordered version. Because if we're making bar plots, we should always order our bars. Unless we're using a time series, in which case don't use a bar plot, use a line plot. But so let's reorder our sites based on the attendance. So we can do a reorder, and we can put that in another function. We want to reorder our sites based on the attendance. 2018, and then this is where it gets really messy around commas and brackets, because we're doing functions within functions and all of that joy. But then, apart from the bit at the bottom there with the site names, but we can now see what's going on there. If we specifically wanted to color in certain of the bars, etc., we can do all of that. You know, that's absolutely not a problem. We could change the color of the bars so that we got a gradient. We can you can set your own gradient color schemes to say that anything under 50,000 is going to be a purple, anything between 50 and 100,000 is going to be a mauve, and anything 100,000 to 150,000 is going to be green, and anything above that red or whatever. So you can sort of set your own specific color schemes if you so wish. There are lots of really nice packages if you want to do sort of color scales, to say I want my starting color to be orange and I want it to end in purple, but I want a nice clean transition from there to there in X number of steps. So I want 12 colors between orange and purple as a transition in 12 steps, and it will give you the codes for the colors and create a sort of a smooth variant to do that. Obviously, I'm not going to go through all of that now because that's just making things pretty, but also really good. And again, if we wanted to add our theme minimal to our, or whatever we wanted, I don't know. I have no idea what all these all do. Theme light. There it goes, just lines up, gets rid of that horrible grey background. And again, if we zoom into that one, we can obviously see that we have got our numbers, and they're a little. It's not quite as messy as it looks when it's all bunched up down here. And obviously, we can do sort of various bits and pieces with that. I'm very mindful it's nearly lunchtime, so we will just do another couple very quickly. Let's do a box plot. So we want to do ggplot data equals, oh goodness me, data equals capacity A. Please copy and paste it from above. Don't be like me and write it out over and again. Wrong. Capacity AE, there we go, plus GR box plot. And we're going to do AS staff increase D weight. So that's just given us a box plot based on whether we've got a true, whether there was a staff increase or there was a false, and the distributions of the weights. So we can see there wasn't a massive shift in the average. However, the actual distribution, we can see it's much, much more skewed this way. And we also appear to have outliers on our weights. I'm going to copy this one this time. And let's do a violin, which is literally changed the word box plot to violin. There we go. And have a look at that. And then we can get a violin graph of our distributions, which is basically like a density plot on its side and mirrored. But we can sort of see the shape, very nice to sort of show shapes of distributions. Can we do... I think we can just copy that in there again. Oops. And if we wanted to, we can add in the individual, try to put some jitter points on there to sort of show the individual numbers that we're talking about when we're talking about distributions, because it's very easy to just go, oh, look at the distribution here compared to that distribution there, but we've only got a handful within our distribution here. So just sort of show it's very easy to sort of layer up those sort of things. And if we wanted to change the color of our points and this one going up or whatever, that's all totally possible. So let's just do some quick tidy up of that. Let's just... So let's just make it a little bit prettier. So let's add some labels onto it. And again, it's just that add. We want to change our title to something. Change in staffing versus weights. And we also want to change our y-axis rather than saying weighting, d-weight to something else. I don't know, average waiting time. Average waiting time. So quite simply, we've just changed, we've added a title, we've added a thing. You can do captions. We can obviously, if we wanted to, we can change our x-axis and do all of those bits and bobs. And then if we wanted to, so we've made ourselves a nice little plot there. Can't see the previous line, has a box over it, so I can't. Which bit are we talking? Which bit are you stuck on, Sigal?
No, just when you type, then a box appears over and hides the line before. So it's really hard to follow, that's all.
Sorry. Have you got it now?
No.
Oh,
Where when you type?
Where's it? Where have you got to? I can go back a bit.
Don't worry, I'll figure it out.
Okay. So say we've made ourselves a nice plot, and then we want to save it. We can just save it if we so wish. So we could, if we wanted to, just click on the export here, or we can tell R to save it for us, and we can just do a GG save plot star weights dot png. Oops. And that will just save it. Let's just do it nicely. What's quite weird and quite interesting that is if we save it, oops, I see what you mean, it comes up with that. If we save it in this format, we'll save it like that. Can't add a GG. Oh, okay. To a GG plot. Okay, I'll get back to that. Don't know. That might be because we're on the cloud. I'll come back to that. That would work normally, and it would save it as a PNG image. What's really quite weird is that it saves it in the shape and the format that you've got it within your window here. So if you've stretched it out here, it will have it stretched out there. There are methods that you can sort of feed through to your GG save in order to specify the height and the save. Oops, sorry, Sarah Houston. Yeah, so there are ways of specifically, if you want to tell it to save in a certain size and shape, you can do that. However, what we're possibly doing either later today or possibly next time around is showing that how we can put our plots directly into output documents. So we can put them directly into sort of either HTML interactive reports, or we can put them straight into Word or whatever, or PowerPoint if we so wish. Yeah, so there's no need to specifically save in a sort of in a plot format. Okie dokie. Any questions vaguely on plotting? I mean, absolutely scratch the surface of what's possible here, but hopefully just to give you a very, very rough idea. But you know, it's just that you can build everything up in layers, and everything is then tweakable and adjustable. So would people rather, I can definitely share code over lunch. Would you rather have, I don't know how you guys do breaks normally. Is it normally a long break? Are we having a 2-hour pub lunch? Who's buying? Or are we having sort of a quick 30 minutes and come back? How do we do things? I'm happy to have that discussion with anybody. I will share, use you 1 hour lunch, 1 hour. Okie dokie. Blimey. All right then. So we're not all going to the pub. Outrageous. Right. Okay. If we do 12:30 then. All right. So we'll make a start onto the next section, but we're not going to get through it. But that's absolutely fine. Okay. Any questions on plotting before we move on to our next bit? Nope. Okie dokie. And as I said, this is just one version of one type of it. Is ggplot is the main plotting type. However, other plots types are available, and I say either the end of today or early part of next lesson, we will look at how to do some really funky interactive type plots, etc. So we are now going to move on to the meat and potatoes of R and do some data wrangling. Oops. Which is sort of a combination of bits and pieces, I guess. So sometimes the data is just simply not in the format that you want, and you want to wiggle it around in that way. Sometimes it's a case of you want to do some sort of calculations and make some new new columns based on the data set that you've got. Sometimes you just want to do some really, really simple, just reorder it or kind of create some functions or do some calculations across groups, etc. So that's all what we're going to call data wrangling, and we're going to use something called dplyr. So wrangling, as I said, reshaping or transforming, and I'm sure you've had a go at that. I'm sure this is going to be a complete shock to you, but sometimes NHS data isn't the cleanest or the most complete or comes in a consistent format. I know. I don't know what to say, but occasionally you might meet that. So hopefully this will give us some tools around how we can deal with some of that if you ever come across such a thing. So a note on tidy data. So we kind of discussed this, or I discussed this earlier, that each variable forms a column and each observation forms a row. And that's generally how tidyverse functions work best. Tomorrow, I keep saying tomorrow, next session, we will have a go at looking at sort of wide tables and converting them into long data, and also looking at some long data and converting it into wide data. That will make much more sense if you haven't used those terms when we actually come to do it, and what the difference between those is. So we're going to be using something called the dplyr package. Because we've got R in the library name, you will notice, especially when you go onto CRAN and you look at things, there are lots of really, really bad R puns, and lots of libraries have got R in them. And yes, there are some really, really cheesy names. Anyway, dplyr is really, really, really powerful for wrangling data around, and we're going to do just 5 of the dplyr verbs, of which there are many, but those base 5 can solve huge amounts of problems and come up with some really funky analysis just in 5 verbs. On our next steps, depending on how far we get today, and on our next session, we'll expand on that and show you how we can do some even cleverer stuff with these verbs. So our next project is to look at mental health inpatient capacity. So we've got some data, and it's based on some real data taken from benchmarking, and we're looking at the changes in the number and occupancy of mental health beds. So as we know, making sure a ward is fully occupied is a serious challenge, so we've got to make sure that we've got appropriate occupancy within our wards, and we're going to look at all of that. The data is based off of KHO3 returns, which has got bed numbers and occupancy by organisation, and it's being published by NHSE and scraped from NHSE website, and it's being partially cleaned, and we will come to that shortly. So up to you whether you want to start a new script or whether you want to continue on from where you are. This does recommend you start a new script, so let's do that. Just so we have got things. So first of all, let's save our initial one. If you haven't done it already, there is a file and save as. I thought I'd already saved mine. Or if you have saved it already, it should auto save as you go along anyway. So that's fine. So mine, if I go into my files here, I have got my training script, and that is last saved at 12:01, which is the last time I actually run anything. So it's auto save as you go along. But obviously, if you haven't saved it, save it. And let's create ourselves a new script. And again, this is something where we can get into some problems with our environments and our scripts. So we've called the tidyverse within our training script there, and I've just created a new script. Because I've already loaded in the tidyverse, that's in memory. That's great, it will work. I can start writing my script right now, and I can use tidyverse things. So if I start writing GG ggplot. There we go. It's going to autofill and it knows that ggplot is installed and it's all good to go. However, if on my next bit of analysis, I just load in this script and don't load in the training script, at the moment, I haven't got a call to load in the tidyverse. So all those lovely tidyverse things that I've written from here on in will fail because I haven't called in the tidyverse. So if you're writing a new script, it's always good practice to, well, it's a fantastic idea, unless it is dependent on another script to call back in your libraries, even though we've got them in memory at the moment, but we won't do if we just come back to this after lunch. If we shut down over lunch and then come back to it, it won't be there within our script. So let's just call it that. And I'm going to call this our training dplyr. And that would also mean I'm going to be nicely saved as I go along as well. So I've got a new thing there and we're all good to go. So now if I shut down completely and open up my training dplyr script, I've got my library tidyverse and it's all good to go. I mean, we can load it back in. It's not going to do anything because it's already there. Okie dokes. Does that make sense? Good, good. So our next bit in is we want to load in our beds data CSV. So hopefully you can remember, and also just to note, by the way, that we have still got our capacity AE in our global environment. So if I've wanted to, even though I'm on this different script, I can do head capacity AE if I wish to. And there we go. It will bring up the head of capacity AE because it's in my global environment. What's important to note is if I save everything and, you know, go and have lunch and then come back after lunch, I'll run my tidyverse, that will load in. I will then go into my capacity AE and it won't be there because I would have flushed it after I've, you know, reset, because I haven't told R to keep a copy of my environment. So if I wanted to use capacity AE in a new script, I'm going to have to sort of load it in again. We're not using capacity AE in this data. It's just something to be aware of, which is why doing that, saving the environment and then coming back into it and then doing something on another script can become really, really dangerous, because at the moment I could write a whole bunch of script that does stuff on capacity AE. I'll come back and I'll share this with you and then you'll go, well, I haven't got capacity AE, it doesn't exist anywhere. So anyway, right, we want to use beds data. So we want to go back up to our import data set and we want to use read R again. And we want to use browse and we want to find beds data and open. And again, it will come up with a little preview for us.
Hi, Simon.
Hello.
Hi, sorry to interrupt. Could you just do that bit again a bit slowly, because my computer crashed after the last break and I missed it.
No worries, no worries.
Thank
so
you.
make sure we've got tidyverse installed, then we want to go import data set from read R and then browse, and hopefully you still got uploaded your beds data and open.
Yeah, that's great, thank you.
So we've got a few problems now there. I hope you can see. First of all, we've got an absolute classic of NHS metadata at the start of a file, which is really frustrating. So what R's done is read the top ones, and we've got a title, we've got KHA referees, then we've got some blank spaces, which is really annoying. Our actual data that we want starts on the third row. But thankfully, we've got some nice little functions where we can, a nice little bit that we can change that. So we can change it to skip the first 3 rows. So we've got skip here, and then we just click out of that. And it should refresh. and that's given us our proper headers for our data tables. Does that come through with everybody? So now our headings are date, org code, org name, beds, av, and occ-av.
No, sorry, I missed that. Could you just do that again, the skip bit?
Yeah. So if you've got it with the old version, just basically put a 3 in your skip and then just click out of it. And it should then just skip the first 3 rows.
Yeah, perfect.
Yep.
Is there a way to go back and do that after you got ahead of yourself and decided to just copy and paste the code in before skipping, like I did?
Getting excited. I know. So yeah, I mean, you can just basically go back into it again and start again. So browse again. So yeah, just cancel out of it and then just go back in again. What are we on? Beds data, open.
So will that replace what's already been
It will
loaded?
start writing some new code and you just copy over it. Yeah. So just to show you, if you just press import now, just to show you what that would do, it would create a beds object, data object. What it won't do is paste the code in for you. So you don't want to do that. So that's given us our data there. We've also got another bit of a problem in that our date is come through as a character format rather than a date format. So we want to tell R that that's a date. So in Excel is like everything's a date. It treats everything as a date unless it's told not to treat it as a date, which is really, really frustrating in some things, but kind of nice in others. But R doesn't do that, and we need to tell it it's a date. So we can click on our little arrow next to where it says character, and we can tell it what type of data item that we would like it to be. So we would like to import that date as a date. It will then ask us what format it's in. So it defaults to nasty American version, which we don't want to do. So we want to change the M and the D around so that we can tell it that the first one is our day, and our second one is our month, and then our Y is long format, year. So make sure you got $D, $/$M, and then Y. And then if you press OK, that should then do us a new preview and convert it into date format, which will put it into ISO format for us. Does it matter M or M? Yes, it does. So a capital M, I was just trying to remember, what does capital M do? So there are different formats depending on how your month is selected. So if it's got the words, then you can use a B. Yep, year is first now, that's correct. If you've got like a column that's got like 01 September in words and then a year, you can put that in there. We've got a capital Y on ours because we've got a full year. If it was just the part of the year and it just said 13, then you could use a lowercase y to cut that out. So there's various different ways. There's also a really, really nice package, which I found recently, where you can just feed it the messiest dates in one, even if they're in the same, you know, when you've sort of sent out those, here, please fill in this this Excel sheet, and you don't set the formatting for dates, and you come back with 50 versions of a date, because the amount of ways you can format a date. There's this amazing package which just sucks all of that in and then converts it into nice date format. But anyway, we're not going to do that. We're just going to try to change it within our date here. So we should now have our date will be as a date, and it's going to put it in a nice ISO format for us. All code is a character, and these are all coming through as doubles. And also, just to note, it appears we've got some NAs and some missing data. So
Simon, sorry. On my screen, I can't actually see the data preview section. It's just completely collapsed. I don't think my import text data is big enough.
I'm just going to bring mine in, so I've got it again. So what's it done? It's just not coming through with anything.
Yeah, I imagine it's there, but just the whole box isn't big enough to show the preview. It's just got the column headers along the top.
Yeah. I'll pop this code into the chat. I mean, does the code come through on the bottom right out? You can't even see that.
I can see the code, yeah, but I haven't managed to format the dates yet because
you can't see them.
Yeah.
Don't know what that is. You must have somehow clicked and dragged it. If you copy the code that I've just put in the chat, that is the correct version.
Okay, thank you.
Good work. I don't know. We'll have a look over lunch if you want. So
thank you.
There we've got some data. Might be a screen size thing. Yeah, I don't know. So now we've got another object up here. We've got our view beds data, so it's pulled that through. We can double check. Another really good way of just double checking that your date is in a date format is by clicking on it and seeing which way it sorts it. So whether it sorts it by date or whether it tries to sort it alphabetically. So you should have year, month, day, which is the default for dates within R. There are ways of converting it back into English readable dates, but generally if you're using dates, it's best to use that sort of format because obviously it works much nicer, especially if you're trying to order things and do bits and pieces. Okie dokie. So we've got dates, we've got an organization name, code, organization name, and if we click on an organization, we see we've also got a bit of a time series as well. So for each organization, we've got a time series of data. If I click on that one as well, yeah. If I click on that and then that, does that order it? There we go. So yeah, we can see we've got a time series of data for a bunch of organizations. We also have some organizations with some missing data sorted. Fabulous. Good. So hopefully everybody's got some data, and just we could do that summary as well quickly as well, which is always quite nice to have a look at. Summary. Data. And there we go. We have got bunch data. Tell us, it's quite nice. It's obviously even on the date, it will tell us the min and max, which is quite nice just to make sure that your data is encompassing the period that you wanted to. We've got organization codes, which obviously is just strings, so there's not much it can tell us about that. On our beds average, we've got our min and we've got our maxes, but it's also told us we've got some NAs in there, which is also quite nice to know that we've got those. And same with the occupant average. So that's quite a nice, really simple function to just run on your data when you first get it, just to get a bit of a sense of what that feels like. There is an amazing package called Data Explorer, which I'll show it to you next time, where you feed it a new data set and it will analyze it for you in the most it will do like cross correlations of everything, give you frequency tables for every single one of your variables within there, and do huge amounts of really clever things on it, all from just one command, and it gives you like this 5-page report on your data, which is just amazing. It will analyze it and tell you where it thinks there's outliers, what correlates with what, etc. Which is fab. Anyway, that's by the by. We are data wrangling. That's what we are doing. Get with the program assignment, right? So we've got some data in, which is a good start. So we've brought in a less of a friendly CSV, and as you can see within our read CSV, let's just make that a little bit tidier. We can see that we've got we can add loads of different things on there to coerce our data into a nicer way in a thing. So you're not getting date as the date. So let's just double check you've done that correctly. So import data set from text, read R, browse, was it beds data AE? We want to skip the first 3. Then it was important to tell it what order that our data is in. So we want to change it to a date, and we want to change that one to a D and that one to an M, because we've got date, sorry, day, month, year, and okay. If that's not working, so go check the date, sorry, the code that I put in the chat and see if that differs from what you've got. Obviously, that's just trying to coerce the data at an import stage. There are ways, and again, we probably catch that at a later point. Once you've imported your data, you can also then convert it into different types if you wish, and we can cover that next time. And we probably will do in a few things, because there are some other really nice data types that we can play with. One of them is called factors, where you can basically convert a string into a factor. So you can make low, medium, high, and you can order things by low, medium, high. Or if you've got a set of teams that you always want to show in a certain order, so you can make sort of categorical data and give them a ranking, which is really nice. So you can do like low, medium, high, agree, disagree, etc. Hopefully you've got a date now, Sir Guile. I assume that you have. So let's just have a look at our data. So just looking at the head of it, so this is real data, so there are some real issues which we will come with. Like I said, we've got a date. Hopefully that has come through as a date now. We've got organization code, which obviously links to the organization name, and that's just a one-to-one check. And then we've got something called a beds av, and we've got an occupancy average. So that's just the average number of beds for that month, average occupancy for that month. And then we've got these lovely NAs, which we will have to deal with. So we're going to have a play with dplyr, and we're going to use 5 main verbs, which are arrange, filter, group by, and summarize. They don't sound that amazing, but believe me, you can do magic with these bad boys, and that's what we're going to do. So building with steps, and that's the really nice thing about how dplyr works, is that they aren't necessarily used independently of each other, and it's a kind of a step-by-step process, and then you can make these amazingly beautiful analytical pipelines where you just sort of pipe the data from one to the next to the next to the next. So when I make our mashed potato, we start with our potato, we peel it, we slice it into chunks, we boil it, and then we mash it, and we end up with our mashed potato. And that's kind of what we will do with our code. So we start with our object, which is our potato. We'll add a peel function to it. We'll do our slice, we'll do our boil, and then we'll have an output of mashed potato. I don't know why I'm talking about mashed potato. It wasn't my idea. So in tidyverse syntax, we've got our input object, which is our data frame. So our beds data or whatever. And it's all about do this to it, then do this to it, then do this to it, then do this to it, and then output it. Which, oh, good, this is old school. All right, ignore that. So basically, we start with our data frame, and we have these things called pipe operators. This has changed in the last 6 months, or it might even be a year now, that it used to be the pipe operator symbol used to be that, which was percentage right hand percentage sign. It's now changed to that, which is your, I don't know what the name of that is, up and down line, just off the head of I will be finishing in 2 seconds. I will finish at 12:30. Yeah, that's called your pipe. And basically it's just shift, and it's on your left hand side above your sort of the left hand backslash and then greater than. So it's a 2-part, but that is absolutely synonymous with that. They both mean exactly the same thing and work in exactly in the same way. If you go onto Stack Overflow or older code, you will definitely see these. More modern code will have these. Okie dokie. I'll just double check where we are for. We've done that. Sorry. We've done some potato. We've done some potato. Do this. Do that. Yeah. So rather than getting on to the actual question, look at that. Absolutely spot on for lunch. So I understand we have an hour. So we'll come back at 1:30. Any questions before we break up? Has everybody got the data in? Is it looking in the right place, etc., etc.? Is there a hotkey for the new pipe? Yes, there is. I think it's the same as the old one. I'm trying to remember what it is. I don't know what it is because I don't use it off the top of my head. There we go. Control M. Control Shift M. But I find that Control Shift M is 3 button presses, whereas Shift pipe right arrow is also 3 button presses. So is that actually faster? I don't know. So Control M, did you say? No, it's Control Shift M. Oh, and I've got it set up. Yes, you press them all at once, so faster. Well, not with my fat fingers. We can argue about that at another point. At the moment, I've got mine defaulted to set to the old version. There is an option in global options somewhere to change it to the new pipe, which is, where is it? Is it code? Oh yeah, use native pipe operator. There we go. I click on that one and OK. My Control Shift M is now using the new pipe operator. So Control Shift M, not. Oh, sorry. Yep. Options, tools, global options. Code. And there's an option here, use native pipe operator, that one there. And you tick that one. Sorry, yeah, tools again, so yeah, tools, global options. Look. And then code, and then use native pipe options. Okie dokie. Any other questions? In that case, I will stop sharing and see if I can work out how to pause the video. That one there, I think. Cool. See you at 1:30. Okie dokie. So I've just saved my script in the I've popped it into the Slack. Just saying, if you want to download your code yourself, you can. So normally when you save it, it would just be in your normal file folder, and there it is, and it's just a normal folder. Obviously we're using the cloud at the moment, so this is our virtual folder, but you can click on a script that you want, and up here in more there's an option to export, and you can just download from there, and it will just download whatever you've chosen. So in our case, it's just our training script that we're doing. So if you want your own personal copy when you've all finished and you want it downloaded onto your computer, and then hopefully you can run it on your local instance rather than using the cloud, that would be fine. Obviously, as far as security and bits and pieces going, obviously this is using cloud. All the data that we're using at the moment is all synthetic. It's obviously not patient level or anything like that. Obviously would not recommend using Opposite Cloud for anything that's got patient identifiable information in it. Obviously use your local and secure systems. Righty-ho. So we was deploying, I believe. So if I can find this back up again. So using dplyr. So we're going to use dplyr to remember to share my screen. That's what I'm going to use dplyr to do. Where is that again? Share screen. That's the one, isn't it? Yeah, I will do. Sorry, Nikki. I was literally pointing on my screen when I was doing it, obviously, but you guys didn't see that. So I'll just go back to here. So within my files here, if I want to download one and have a local version, I can click on my script, tick that there. There's an option here for more, and then export, and then that will just download it onto your computer. Let me just get rid of that. And I had it earlier. I had the chat up all nicely. Let's see, where was that again? Oh, there we go. Right. How do you change the name of the y-axis? Sorry, I'm just going back to questions, make sure that we are right. So we did have here when we were going to save our plot, but it was not add labels. We can do a plus, and then we can do labels, and then go back to this, go back to our nice plot. We can change our labels, we can add a title, and then we did a y equals to change our y into average waiting time rather than what it was. And how do you change the range of the y-axis? Oh, sorry. Yeah, so we can do y-lim, and say we just want to do a range between, I don't know, 0 and 75. So we can just do, just try to remember which order it is. Do we have to do it as a, how do we feed it in? Set scale limits, that's the one. 2 numerics. Yeah, so we can just do 0, 75. Where's that go? There we go. And that's chopped off the range of our data. So we've now changed our limits to 0 to 75. Obviously, it's giving us some warning messages here that we've removed a bunch of rows from our data set. So we're not plotting the entire data set. So it's just giving us a warning that's the case. So we could make it bigger if we wanted to. So we could do minus 75 to, I can't remember what it goes up to, 275. Yeah, and you can sort of squish them down and change the range of the y-axis if that's what we want to do. And obviously if we want to change the x-axis, then we could put a xlim in there. Hopefully that answers your question. Right, go back to dplyr. And as I said, each and every single thing within that plot is up for grabs, and you can change it and tweak it however you want. Have the text all slanted and whatever. Right, dplyr. So we want to know which organisation provided the highest number of mental health beds. So if you remember back to our data, we've got obviously information on the date, we've got information on the provider, and we've got number of the beds and average occupancy. So we've got our beds data, and this is still the old version. We're going to use the new pipe because we're cool kids, not the old pipe. I'm sorry about that. I need to make sure we get these slides updated. And then we're going to arrange our beds average to basically put it into order. So let's go back to our code. And we started off a new bit of data. I started messing about with pipes, so let's get rid of all of that. So we are going to start with our beds data, then arrange on whatever it was called, just trying to remember, beds av. Beds av. So basically all that's going to do is just sort that column, sort our data set by that column. So if we run that through, again, it's just going to come out in the console here. So we're not creating a new object or anything like that. We'll discuss that at a later date. But basically we can see, well, actually we can see the lowest because it's ordered it that way. What we want to do is order it the other way. So let me just make our I'm just going to make it nice and pretty in this version. So obviously that's come through in the incorrect way that we want it. So we want to order it the other way. So simply, that should have come up with that as it has done. But what we want to do is arrange it in descending order so we can add another function. So we can arrange descending beds av. So if we put a descending function in there. Yeah. Okay, there is another sneaky way that we can do that rather than descending. I'm sure you've done them in Python the same. So you've got all your normal operators. You've got your equals and your greater than, less than, or whatever. But there's also the not operator. So what we can do is arrange and put a not in front of our beds average, which will again reorder them in. Oh no. That hasn't worked at all. Forgive me, I am talking nonsense. We'll use that later. In order to get the descending, we do need to use the descending. Yeah, sorry. Yeah, we could do a not descending and it would put that as ascending. Okay, sorry, that was me talking nonsense. Order descending. So hopefully everybody's got Nottingham Healthcare was the highest beds av overall. Right. So I meant stop going off piece because it makes you sound silly. Right, going back to here. So just to say, descending and the ascending also works for text and numeric variables as well. So if you put something in descending, if we did a descending on org name, it would put them in reverse alphabetical order. As I was saying before lunch, we can also create factors and have a hierarchy of things. So we could have low, medium, high, highest type things, and then we could order by a specified category, and we can create our own categories. So yeah, that becomes really, really powerful, that you can make your own categorical variables, and they can be so that your sites always come out in the order by what STP or whatever ICS they're assigned to, or something like that. So you can do some really nice sort of arrangements. So that's kind of answered that question in a really, really simple way. So on our question 2, which 2 organisations provided the highest number of mental health beds in September 18? So similar sort of thing. We already know how to do our the highest number of beds. That's fine, but now we only want to know in September 18. So we want to use a range as we did before. So that's exactly the same as it was before. But now we want only the observations from September 18. So basically we want to add a filter into our pipeline. So the filter does what it says on the tin. It picks observations by a value or a rationale. So within this, and you guys are Python users, so absolutely no problem. Same as you would within Python. If you're doing a test of equality, then we need to do the double equals, whereas a single equals is like is. So I always say single equals is. So you're actually assigning this is that. Whereas if you've got a double equals, you're saying is equal to and then that. So it's a test of equality. So we want to get our beds data, and our date is equals to 2018-09-01. And that will basically give us a filter that we can filter through. So we can also do a question mark, exclamation mark equals to do a not equals to. Which we could do. We could also do a greater than or less than, and all of those sort of things as well. So going back to our data, we want to get our beds data, we want to arrange it, and then we want to filter it. Absolutely no reason within this particular pipeline that we're creating that you couldn't do it the other way around. You could filter it and then arrange it. So that would work just as well. So I'm going to cheat and copy my code. Let's go back a minute. Just going to copy the question so that I've got that in. Makes it look pretty when I go here. That over, as we're doing more dplyr stuff. Same with VS Code, we have got our little line of do not cross. So we want to get our ordered beds data. Then we want to filter, and it was, what was it called? Date. Date is equal to 2018-09-01. Oops. So we should have East London come up. Is that right? Have I done 2019? Is that right? Yep. So basically that's what we're doing. So each time, let's say we see this pipe operator, we're doing a then. So we're getting the beds data, then we're arranging it, then we're filtering it. Any difference between using single and double quotations? Nope, absolutely fine to be interchangeable as long as you're consistent. So you can do that if you so wish, and that's fine. What you can't do is mix and match. and do that because it will throw a wobble. Oh, that's something I should probably explain. So if for whatever reason, and you might have encountered it before, you've not closed off a bracket or you've not closed off a quotation and you run something. So we've run this. Oops, sorry. Let's just run this little lot here. I haven't finished off my, so I haven't got a matching bracket. So here, so this now has changed into a plus. So it's kind of asking me like, and what? Because I haven't finished off my either my quotations or my brackets or whatever. What I can do is if I can notice there, I can just put in my closing bracket there, and that would, it would then feed that in and it would run, and then I can know to put that in here. Obviously, I've got a really nice little syntax thing there telling me I've got an unmatched bracket. However, sometimes I don't know what it's asking for there and it's just kind of stuck. And if I just press return or anything like that, it will just go crazy and just carry on. So you can either put in gibberish, at which point it will come up with an error message, or you can just press escape on that and it will quit out of that, waiting for the next thing to come along. So let's tidy up my my data here and put in my in my code and put in my finding ground. Okay, so what you can do is do mix and matches sometimes if you're writing text strings. So you could write a text string which includes quotations, which is where you would get really confused. It's not a good idea, but you can make text strings with quotation marks inside them. But it does get really, really messy. I'm sure you guys have had it as well when you've done print strings within Python. If you just happen to want to do a /n or one of the regex type things, then there are ways of getting around it if you want to actually print a /n rather than using it as a new line. And there's ways around that, and that's one of the ways you can do things, is put things within quotation marks, within double quotation marks. It's, yeah, but anyway, we're not going to get down the whole regex thing. If you start writing lots of really funky text, then maybe that's something you need to look at. Okie dokie, where are we? We are, so we've done that one. So we've had our beds data, we filtered it, we did our test of equality, we got our double equals. I mean, that's one of my favorite and most read error messages, I must admit, is when I do the single equals. And I will come up with the warning. We've detected a named input. This means that you usually use single equals rather than double equals. Did you mean date double equals? And it's like, yes, that's exactly what I meant because I got it wrong. So that's just a really beautiful example of a meaningful error message, which A, tells you've done something wrong and suggests how to fix it, which is great. We should have more systems that do that kind of stuff. So we've done our filter. So let's get on to a trickier question. So which 5 organisations had the highest percentage bed occupancy in September 2018? Okay, so let's kind of work this all backwards. We've got 2018 we can do. We can work out the highest of something, so we can do our range. That's fine. However, what we haven't got is a percentage bed occupancy. So we can use a range for our highest, we can use filter. However, what we don't have is a percentage bed occupancy. What we've got is the average. I can't remember what we have got. We've got the average and the occupancy, but not as a percentage. So we want to create a new variable. So yeah, we're going to create it. So what we can do is do something called a mutate, which basically does what it says. It mutates your data frame and adds in a new variable, and we can create that from existing ones. So we're going to get our beds data, then we're going to mutate it, and we're going to create a new variable called perc_occ, which is our percentage occupancy. And our percentage occupancy is our average occupancy, average occ divided by our beds, average beds. And that will create a new column called perc_occ. So let's do that. Let me just copy the question. And so all the other bits should be the same. So we want our beds data. Then we want to mutate. We're going to create a new column, which is going to be perc_occ, and that is, so this isn't about inequality or whatever this is, and it will be our occ av divided by our beds av. Is it the right way around? I can never remember. I got it the wrong way around. Oh, I got it the right way around. Look at me. And then, so just to remind us, it's not a test of inequality. And then we want to do the same filter as before, so we can copy that. But now what we want to do is arrange our data based on our new perc_occ we've just made. So we've created something called perc_occ, and then within our pipeline, we can call it. So this is where it blows my mind, especially if you're a SQL user, that you can create a new variable and then instantly use it. So none of that group by kind of craziness and subqueries and all of that kind of stuff. You can create a variable and then straight away instantly use it within your same pipeline. And I'll show you later how crazily bonkers that can get. So we've got our beds data. We want to mutate our new perc_occ, filter it by our date, and then arrange it, like I say, descending based on our new perc_occ straight away. And that's where sort of building pipelines gets really, really clever. And you can start doing some very, very clever things. That's given it old school ones. Let's just change those to new school. Oops. And what's also really nice is that you can just kind of hover over and run everything bit by bit and see how that builds up. So I can just start with my beds data and I can see that, yeah, I've got this divided by that is 0.97, yada, yada, yada. Obviously, I've got some NAs that's not coming through. That's got all the data in there at the moment. I can just run it before then our next pipe, run that. See, that's gone through. So I've definitely got my filter now and it's still doing its joining. And now what I want to do is arrange it on my new column here to bring out the highest of our perc_occs. So if I run the whole lot, so I'm just going to do Control Enter at the end, I can now see that we've got a bit of a weird outlier here. So I don't know why they've only got 2 and 2, but obviously that's given them 100%. And yeah, we've now ordered our data directly on this new thing. So yeah, we could do an absolute limit. So there is a slice the n no row, is it n slice? So we could do head 5 as the simple way of running that through, and that will give us our top 5 that way. Just trying to remember, there's a slice way of doing it as well. I can't remember what it's called. Oh, slice head. which is a dplyr way of doing things, but it should come up with the answer. We'll come to that later when we start talking about objects, around the difference between assignment operators and equals. Essentially, n equals 5. Look at that, another useful error message. Look at that. That giving me, yeah, there we go. So if we are going to do assignment to a variable, yes, you can do equals and you can do assignment operators. It's quite nice in R that we generally use assignment operators just to keep those two things separate, so that we have equals within functions, and when we're assigning things to objects, we use the assignment operator. So generally it is good practice to use assignment operators. We'll do, once we've done a few more of these, I'll show you how we can use objects and explain what I've just talked about to Michael, who probably, or Mitchell, sorry, who yeah, put a chess question in the chat. So that has given us some data there. So we've got our beds data, we've mutated it, we've created a new function, we've filtered it, and then we've arranged it based on our new function, and then we've just selected the top 5. So our next question. So what was the mean number of beds across all trusts for each value of date? So hopefully that makes sense. So basically we're going to we want to create a bit of a grouping and work out for each date what was the average number of beds. So we're going to do some groups. So I'm just going to put the question in here because that's kind of useful. So we're going to start off kind of at the backwards and work out how we can do summary statistics like a mean, etc. So first of all, we want to get our beds data, and then we can use something called summarize. And that basically collapses lots of values into a single summary value and or table. So think of what we've been doing so far, and horrible to use an Excel analogy, but that's what we're going to do. So at the moment, we've been doing filtering and sorting and creating new variables, and that's kind of what you would do on your bog standard normal bit of Excel, and that's fine. However, if you then wanted to start grouping things and adding in means and stuff like that, you would probably pop it into a pivot table and create a pivot table, which was like your summary data based on your raw data. So that's what summarize does. It's kind of creating that sort of pivot look of things. So we are going to get our beds data, and we're going to do a means bed. So again, we're creating a new variable, and we're going to use the mean of our beds average. And hopefully you can copy that and get that to run. And when we run it, oh no, it's gone wrong. It hasn't worked. We should get a nah, which is bad, because what does that mean? What that means is we've got messy data, and we've got some NAs in our data, and it becomes quite important to understand what to do with our NAs if we're creating an average. Obviously, if we've got an NA, we can either count that in our denominator or not, and that's where it all gets a little bit confusing. So do we include them? Do we remove them when we do our calculation? We haven't explicitly told what we want to do, and so we need to tell it. I'm just going to put the above does not work because we have not specified what to do with nah. R also has nans, which I do believe Python has as well, when you've got not a numbers as well, and those can cause issues as well. So let's just take our mean, and we just want to add an extra feature to our mean. So after our beds av, we want to do NA dot RM equals true. So basically, we want to remove our NAs from our mean calculation. And then when we run it, we get ourselves an average, the mean average. But obviously, that's across the entire data set, not as per the question where we want it for each value of date. So we want an average per month, not just the average across the entire data set. Everybody got their average to work? So yeah, comes through and then we want to remove. We can also put a true as a T, but again, I'm old school. I like doing long format to understand that. And exactly the same as a Python. If you've got a conditional, so if you've got a true or false, which I probably should have mentioned when we were looking at the graphs earlier, under the hood, it counts trues as ones and falses as zeros. So if I wanted to count how many trues there are, you can just count, you can just do a sum of your true falses, and it will give you a number nice and easily without having to do lots of horrible if statements and things. So if we change that to mean and remove nulls, that gives us a number 300, but obviously summary across the entire data set. What we want to do is for each value of the date. So we know how to summarize now. We've got the mean value. Now what we're going to do is just do that grouping of dates. And I think I've let the cat out of the bag that we want to do group by. So what we want to do is basically our beds data, group it by our date, and then do a summary. So group by on its own doesn't produce anything. It just pulls stuff together in order for the do something for the next part of the pipe. So group by in itself, Jamie, to everyone. If it were NA, would we recode it to NA? Yes, it depends what the data looks like when you feed it in. So we fed it in and it was definitely numeric data with some NAs in it, and NA is an applicable thing for a numeric data. If when we fed the data in, we told it that it was, we coerced it to being numerical, but it had N/A's in there and they were like hard coded in there somehow as text, then they would show up as nans because it's saying that there's not a number in this numeric data set, which would be the same things we could do. NA removes nans, and there's lots of nice code functions that do like NA omits and removing all your data if you've got nulls in there. There's also really nice data which I'm sure you've done, really nice functions which you've probably done with some of your machine learning stuff. So you can impute missing values, and we can do some sort of conditional stuff that we can recode stuff that if we've got an N/A, we can change it to the average, or we can just change it to 0, or change it to an NA or whatever. So we do conditional stuff and bits and pieces later. So group by in itself doesn't do very much, but then obviously we can summarize. No worries. So now we have done that, my computer has frozen. Oh, we'll come back to decimal. Where are we? Sorry, let's go back. So let me just copy that. So there's a couple of things here. Within our data set, it's come back and it's given us an answer. So we've run through that. It's just displaying here within a tibble the answer. Ask me that in a minute. The question about the decimal places. Can you replace by zeros? What if the occupancy is null but the bed's average is not? Yep, absolutely. So yeah, we can run conditional stuff on it to fix the data however we wish. I'll get back to the decimal points when we get onto the next stage. In fact, let's write note to future Simon decimal places. Right, there we go. If we wanted to, we can also do, where are we? We're doing group buys, that's what we were doing, I remember now. We're doing that, and then we were doing look at me and my old school pipes. Sorry, group by. Oh, my computer's going really slow. Right. And that gives us a result per date. Cool. Bingy, bingy, bang. Proper job. Right. What is really, really good practice is if we are doing a group by. So in itself, group by doesn't do anything to the actual data itself. It doesn't create anything. It doesn't do anything. However, it does do things under the hood in that it does group some stuff together. So it's usually best to ungroup your data once you've finished grouping it. So once you've got the answer that you need to get to, just ungroup it. That won't stop it from being grouped from your previous answer. It just means if you then go on to do something else, it's not already grouped. It's not already grouped like that. So you can potentially set up another group if you want to. And it can cause you problems sometimes if you forget to ungroup something and then do something else to it and then go, why is it coming out with these really weird results? So definitely worth doing that. So good practice is just to add in our ungroup at the end. Won't show any difference, but is does come in handy. So where are we? So that's pretty good. Okay, so I think this one's where we get over to you. Ideally, or other things we can do just to show. Let's go back to here a minute. So at the moment, I've got my mean beds equals my thing. I'm not limited to just one thing within my summary. So if I wanted to, I could put a comma after my bit there, and I could do total equals, and then you can just do an n open close brackets, which will give me a total number, give me a count by month. So that's how many there were. So that's the average, and that's the total, the count. If I wanted to, we'll see if you can work out how to do it. You can copy that, and we could do a median, because I love a median. I hate a mean. So and we can do all of that kind of stuff. So that will give us then our means beds, our total, and our median as well. So you can do all of those sort of bits and bobs. And like I say, you're not necessarily limited to one thing. So let's give you a horrible question to have a go at. So this is all stuff we've just done. Absolutely. So, and there will be lots of help along the way to answer this question. So this is the question we want to get to. So which 5 organisations have the highest mean percentage bed occupancy? So I'm just going to pop my question there. So break it down over the 5-year period. Right. So let's break it down. We haven't got percentage bed occupancy. We've already worked out how to build that in one of the earlier bits. So we want to use that. We want it by organisations, not by date. So that's how we want to group our data. We want a mean, so we want a summary statistic. So we want to use our summarize. And then we want the highest based on what we've just created, our new mean. So a good tip, like I showed you earlier, is that you can run your R code at each section just to make sure that it returns each bit that you want. Acute hates means, not outlier resistant. Absolutely. And it annoys me no end when people start using mean lengths of stay, and especially I usually work in the mental health or learning disabilities arena. Yeah, we've got a patient in one of those arenas who's got a length of stay at the moment of 28 years. So using a mean with that patient on any level is just absolutely bonkers. So median is definitely the way forward there. If you are feeling really, really clever, you can also look at the mean function, and it does have a trim function. So you can trim sort of the ends in order to get a trimmed mean, which is really, really quite nice as well, which is another way of possibly getting rid of some of those outliers. And like I say, that's just all built into the mean function. So this one's over to you guys. I think there's a helper bit. Yeah, over to you. Oh, there's a hint. And I'll just sit back and drink coffee. I don't know. Hopefully not too loudly. So the trick on this one, and what throws most people, is that you are feeding in stuff you've just made into the next part of the pipe. So just bear that in mind. And especially if you come from a purely SQL background, that's just impossible, and you can't do that. And that throws lots of people. But you guys are Pythonistas or Python, I don't know, is it Pythoneers? I don't know. Python peoples. So you'll be absolutely fine. Anybody got an answer? Anybody not got an answer? I don't know how to play this. Right.
Mine's tripped up at the arrange line.
Okie dokie. What's it saying?
Object percock not found, but
Okay,
it found it earlier. So if I run just my beds data and my mutate.
So in your mutate, what have you called it?
Percock, perk underscore ock.
And in your summarize, what have you called it?
Yeah.
So I'll start running through it. So this gets a little bit confusing because we are we are going to create, we're going to arrange based on our summary, which is based on our mutate, which is a bit of a mean thing to ask you, but hopefully it shows the power. So first of all, we want to create our beds average, which is up here somewhere, isn't it? That one there. Our perc-oc. So literally we can nick that bit there. So that's fine. Let's stop. So just checking that. We have got we've got a new perc-oc here for each of our bits. We then want to group it by our whatever it is, org name or org code, doesn't matter. I'm just going to do org name. So that's just going to group it by org names. Then we want to find the average of our percentage occupancy. So this is where it all gets a little bit confusing. So we want to optimize, which will be our mean beds equals mean of our perc-oc, which I'm going to nick from there, and then ma.rm equals true, and I can't spell. So it should be a dot, not a comma. And then, so if we look at our data at that point, we've created a summary, but we haven't got anything called perc-oc now because we've created a summary by org name and we've got an average of our mean beds. So now I just want to arrange it by our mean beds. Mean beds. And then let's be good and do an ungroup. And then slice head n equals 5. Bingo. That makes sense. Have you got that? Happy to talk that through again because it's a bit of a mind blow. Do you want me to go through that again, anybody? Or has everybody got that?
Simon, can I just ask a quick question?
Yes, you can.
So I'm a bit confused about when kind of attributes are available. So, you know, our kind of attribute means beds becomes available in our arrange function.
Yep.
But are you saying that the kind of attribute perc-oc at that point isn't available?
Yeah, because we've grouped it by organization name and made a summary. So if we look here, when we do our beds data, we've got our raw data. And if you can imagine, in Excel speak, we've added a new column to our base Excel table. Yeah?
Yeah.
So then when we've done a group by and summarized it, basically we're now putting it into a pivot table.
Right. Okay, fine. Yeah, I'm with you.
So we can't then use perc-oc because it's in the main data set. We're now working on a pivot table.
We're kind of dealing with the transform data from here on in, aren't we? Yeah. Okay. That's fine. That explains it.
So now when we look at it at that summarize area, we've now got a summary by organization name and just our bed state. So that's just our pivot table we're dealing with now. So we've only got what's available in our pivot table, and then we've arranged it.
Cool. And that's hence the earlier statement about when you want to, at the end, doing the housekeeping is kind of ungrouping the data. It's kind of restoring it to its
kind of
natural state kind of thing. Yeah.
I mean,
cool.
You can do absolutely crazy bonkers things, like we've created here our means beds, where we've created literally a means bed. We can do a gibberish variable within our summary, which will be mean beds, mean beds plus 10, right, for no reason whatsoever. Okay, so we've created a summary variable here called mean beds. We've done a comma, and then we can instantly call it straight away into our next bit. So now if we do this summary, we will have our gibberish variable in there as well. So as soon as you've created this mean beds there, it's instantly available to use, which is just phenomenal. So there's none of that having to create stuff, and none of that like calling variables and setting them and all of that. You just create them on the fly, as it were. So that now exists there. So I've got my gibberish variable, which was based on my mean variable, which I built in the same summarize command. Does that make sense?
Yeah.
But that does mean you can do some really, really powerful things. Would we need to calculate a total first for each organization before creating the percentage to avoid doing the average of percentage? Yeah, I mean, generally you wouldn't do an average of a percentage. That's bad form. But for just this example, that's what we're doing, just because that's the data set we've got in. So yeah, there's definitely dodgy bits about how we do our data. So got a note here from past Simon saying how do we do decimal places. So at the moment we've got a mean beds, and we've got a result with 3 decimal places. So basically we can stick our answer within a round function and round it. So we've got a mean beds there, so we can put that within a round function. Let's round it to 2 decimal places. Again, this gets, when you're putting functions within functions, it gets really messy around commas and brackets. So but if we run that now, hopefully, if I remember I've got it right, we're now down to 2 decimal places. And if I change that to dec, oh, I haven't actually done it up here, but if we do dec equals sign 1, I'll do that in a minute. That's our next thing we're going to show. And we can run that, and now we've got it to 1 decimal place. Yes, we can. So depends how we want to do things. So can you display it as a percentage is the answer. So yes, we can, and there's a couple of ways of doing that, and it depends for what purpose we want to do it. Generally, if we're doing calculations and stuff, it's 100 times easier for it to be a number, because you can work with that. If we want to create this as a table, which we're going to output and obviously show to users, we'd want to put a percentage sign on there, and we'd do that when we do our stuff on the next bit, where we sort of show you sort of outputs, etc. So you can then format it as a percentage. So yeah, absolutely, but that's more for outputs. This is where us as analysts who deal with numbers rather than percentages. But there is a package which will allow you to convert it to a percentage within your data and work with it. It's just a little bit harder to work with. And yeah, to be honest, the actual percentage signs, that's much more useful when you actually sort of come to outputs. Can you repeat the decimal bit? Yeah. So basically, I'll just run it through a little bit slower. So basically, there's a round function where it takes x of whatever you want to round, and then tell it how many digits you want to round it to. So for instance, I want to round this to 2 digits. So if I had 12 point blah, 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 and I put that in my round, it's going to reduce it down to 12.21. So what I've done is put my mean here. Oh, the deck bit. Sorry. Yeah. I will go to that in just a second. Yes. So I will do that now, in fact. So as we've been going through, we've been creating these little summary tables, and the only place they've existed is here in our console, and they've just given us a result, and then they've poofed away out into nowhereness. So they don't exist. They literally, it will come through as a result, and then they don't exist anymore. However, I want to have this as a new object. So I can assign my little beds data, objects. My little beds data summary, I want that now to be an object. So I can literally copy all of this lot. I mean, you can do. And again, this is where we were talking earlier about the assignment operator and the equals. Whoops, that's not right. We want it there. So now I'm going to have in front here, beds, sum, and then assign that this query. So my bed sum is going to be my beds data, and then yada, 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 yada. And now when I run that, chug, and it looks as if nothing happens because nothing's happened here. However, if we cast our eyes up here, now I've got a new object, and it's called bed sum. And if I click on that to have a look, as if by magic, I have got my table now, and that is now its own data frame, which I can then feed into pipes and do whatever I want to. I could do plots on that. That's now my new data frame. What I did, I've deleted it now, is created a variable. So I've got so I wanted to put that in a round, didn't I? Round. And I wanted to, originally I did it as a 0.2, but what I want to do is have it so that I can tweak that decimal places occasionally. And, you know, sometimes I want it to be 2, sometimes I want it to be 5 or whatever. So let me set up a new decimal places. Let's just call it something a little bit more reasonable rather than dec. And I'm just going to assign that the number 1. And then if I run that, I now get basically decimal places is 1. But I can then take my variable, and then where it says comma 2, I can put in my decimal places. And now when I run this, it will slice, it will do that. And when I look at my data, it will round it to 1 decimal place on the mean. There we go, down to 1. So if I wanted to, I can make that much, much more dynamic. So for instance, I mean, it's probably not a good example, but I could change that to my n equals the number of decimal places as well. So if I change that to 3 and then run all of that, so not only now will my data be rounded to 3 decimal places, it's also going to bring out only the top 3 results. Is that right? Yeah. So now I've only got the top 3 results. So again, it's really nice that you can feed in you can kind of create variables within your pipeline, which then feed into later bits within the pipeline. So if you wanted to only bring back, like, that's really useful if you wanted to do, let me think, say we've got a bunch of sites and we want to see how much they vary from the mean. quite often we go, well, let's just color all the ones that are above the mean as green and all those ones that are below the mean as red, because, you know, those are above average, those are below average. We all know as analysts that's a really nonsensical way of doing things. Maybe we should use standard deviation. So only highlight those that are a standard deviation away from the mean, to at least give it a little bit of statistical rigor, because, you know, that middle area is just going to be wibbly wobbly and not really mean very much. No pun intended. So, oh, that was a very good pun, sorry. So what we could do is calculate the standard deviation and then just slice our data to highlight those which are who deviate. Okie dokie. So that was that. So yeah, so assigning all these things to objects now. We've done our assignment and we've done an assignment operator. You can do it in a Pythonic way and just do an equals. However, that's just smack on the wrist, bad data, unexpected symbol in. I'll copy. Have you done a then? Let me see. If you paste the whole code in, I'll put my, that's got my gibberish stuff in there. Beds data, mutate, equals. I always get muddled up with the means. Let's have a look. I'll just copy yours and see if I can get it. Sometimes R is a pain. No, it's putting functions within functions. That's the pain. So, oops, let's copy the whole lot. So let's have a look. How is yours different to mine? It is saying I've got something here. Unmatched opening bracket. So you got mean beds around mean. That box is true. Comma. Ah. So that one meets that one. It just. Yeah, unmatched bracket. Yeah. Needs another bracket there. It's always them pesky brackets. When it's not them pesky kids, it's them pesky brackets. So yeah, chuck another bracket in after the 2. Again, that's that really nice kind of matching. That's all right. That's quite nice thing about RStudio, doing that nice matching of brackets to try to work out how's everything going through. And to be fair, it did actually come up with a thing here telling we've got an unmatched bracket, so tries to help you as much as possible, which is nice. So that is that. We are going to have a break shortly, but first we're going to, so in the yeah, let's go on to the intermediate stuff and see how far we get through that. So in the data sets stuff, it wasn't in the data sets, there was a bit of R script called intertrain, which is your intermediate training. So if we go into files and upload that, if you can find it. And I will save this script off and I'll pop it into the so you should have something called intertrain. And okay. So if you upload it and then we want to open it, which is just open file intertrain. So this is a bit of a, here's some code we've run earlier, and basically we're going to run through some stuff, and then there's going to be some sort of code along bits as we go along. So hopefully, so you can do upload, find the file, upload it, then open file and open. So just before we go to break, it will come up. So basically, when you load in a new script, RStudio will run through it and check it for additional libraries that aren't installed. So it's telling us here we've got a couple of libraries that aren't installed. So we haven't used this NHSR datasets, and there's a couple more libraries down further on that we haven't got. So it just scan through and say, hey, you haven't got these installed. So you can very nicely just press the install button, and that will get them installing. Squiz uses 5 million different things, so that takes quite a while to run through and install. So hopefully everybody can get those downloading and installing while we go on break. So everybody got Intertrain uploaded and loaded in.
Simon, I'm getting a permission denied error.
Permission
denied. Yeah.
At what stage?
Sorry?
At what stage?
When I try to upload, so I can choose the file.
Yeah.
When I try and open it, it's saying permission denied.
How are you trying to open? So it's uploaded, it's in here, is it? You've got it, you can see it like
no,
mine.
I can't see it in there. I'm trying to get it into that section.
Okay, so you did trace file and you did Intertrain, open. Yep. Is that still going?
Yeah, I'm getting a file upload error. I'll try and download it again.
Yeah, just double check. Is it, I mean, it's, where are we? 24.7 kilobytes. It hasn't just come through a 0 or anything weird. So upload, choose file. Intertrain and open. You're not clicking on browse or anything weird like that. Nope.
No.
And then okay. Oh well. Yeah, let's just overwrite it. That's fine. And it should just load in there. Still not.
Still getting the same error.
Anybody else getting that? No, but if everybody else is okay, do you want to take a 10-minute break, and I'll just, if you want to share your screen, let's have a look and see if I can sort it. So where are we? We are at 40. So yeah, if we come back at 10 to 3, do you want to share your screen? I'll just see if I can.
Yeah, one sec.
It sounds like we are.
Are you able to enable screen sharing for me, please?
Well, in principle. So who sorry, who am I talking to? I can't even see that.
Hi Simon, I'm Phil.
Phil, hi Phil. Right. Phil Debenham, where are we? How is this saying? Oh, they're in alphabetical. Of course they are. Oh, are they? Sorry, I'm just trying to find you on the list. Ah, they're sort of in alphabetical order, but they're not. If I make you a co-host and give you all of that power, see if that works.
Great stuff.
No abusing it though.
Great responsibility and all that.
Crazy. So what's happening with you?
Can you see
Yeah.
my web interface?
Yeah.
If I go,
I see. You've gone up a level somehow. Cloud. So double click where it says project on your. So cancel that and double click on project. Or do you need to do it? Will it work? I'm just trying to think. Yeah, on the down a bit on the actual file. Oops. Oh no, don't do that then. Click back on our training. Go back to where you were. So basically, I think you've gone up a level.
oh, I see. Okay.
And now it's put you back on the right level anyway. So now if you do upload, choose file. So yeah, on the folder structure, somehow it put you up a level. There we go.
Oh,
Now,
I see. And I think I know. So I think what happened is I clicked browse.
Yeah.
And went in there.
Put you onto cloud rather than cloud project.
I see. Yeah.
So wouldn't let you upload something onto the highest level, which kind of makes sense. So yeah, that's it. And then press the install button up the top in yellow. There's packages, a squeeze bar button are required but not installed, and then click where it says install.
I see. Yeah.
Yeah. And it should. There we go. Should start loading a bunch of stuff in. There we go. Yeah. Proper job. Right.
Thanks, Simon. Appreciate that.
No worries. Share screen again. Well, which one are we on? That one there. Right, back in 5. Oh, there we go. Well, it's time. Blimey. What? You got snow? That's so not fair. Do you need to save as each time as the save button grays out? No, it auto saves on whatever what's this thing called? It's called RStudio Cloud. It auto saves every time you run your code, so you don't have to. You can turn it off of auto save. It also auto saves quite nicely within RStudio as well, so you don't have to save. But if I start writing code and not run it, that's when the save button is not grayed out. So as soon as you've written as soon as you run some code, it will run. Hopefully that makes sense. Good. I hope everybody's back and not outside playing snowmen, which I would be had it been snowing here. It's really not snowing here. So first of all, just going back, I don't think there was any other catch-ups from last time. No, we're all good. So we are starting on a new script. So this is a bit of a Blue Peter. Here's one I prepared earlier. So this is going to go through a bunch of stuff. We are going to finish here about 2:15. I'm just then at that point going to show you some of the sort of quarto outputs that we're going to look at in our next session. So we're just going to do a little bit more advanced data wrangling and some bits and pieces just to sort of show you some of the extra bits that we can do. I'll then do a show off around the interactive quarto. I've just put it in the Slack channel, the output from that. So if you want to play along at the end and have a play with all the different interactive widgets, because they're great fun, you can chuck those in there. But hopefully next session we can go through that in a little bit more detail and about how you can build similar reports. The Quarto example in there is still a bit rough and ready because I only just recently built it. But just to say, you don't have to share it with all the actual R code in there. You can make it just as a standalone report without all the R code in there, which I probably should show that version because it will look much neater and you can have it as a completely finalized result. Anyway, that's all by the by. Before we get to all those funky widgets and stuff, we're going to do some more wrangling, because who doesn't love to wrangle? So likewise, we're going to use the tidyverse again. So we're going to load that in. We're also using something called NHSR datasets, which pretty much hopefully does what it says on the tin. It is a collection of pseudonymized and sort of just synthetic data sets, but based on NHSR data, which is really, really cool. So that if you want to create, if you want some data that you want, or a process that you want to share with somebody, you can point it at these. If there's one of these data sets which is good enough or close enough to what you want, then you can use these data sets. It just means you don't have to share any actual real patient data, because we don't do that. So I am going to, at the moment, still I've got everything here within my environment because I'm working from one thing to the next. However, I want to flush that and start again. I'm just checking. So Darren, going back to what is the difference between equals and assign by, essentially nothing. Except you can only do assign by to assign stuffs to an object. You could do an equals to that. Just in R, we keep them as separate so that we have an assignment is when we are assigning to an object. So an object is what we call either a data frame, a value. Later on, or I can show you very, very briefly now, if we've still got some of our initial script, we can assign a plot to an object. So if I run that, I now have an object called P, and if I call P, oops, it will hopefully today at some point call up my plot. So if we're assigning something to an object, we use the assignment operator. That's just generally, and we could use equals, but it just becomes really, really messy when you're trying to read code later on. So it's just generally good practice. There we go. Right, where are we? So we've got something called intertrain. Hopefully that's loaded up. There was a yellow banner that would have flashed up at the top and asked you whether you want to install all the stuff. Hopefully you clicked yes, and that will sort of chug through, because that takes a couple of minutes. I've still got all my messy old data here in my environment, and we're not going to be using it for any of the stuff we're going to go going forward. So I'm going to flush this. So there's a little broom here, which says hover over clear objects from the workspace. So I'm going to press that. It will say, are you sure? Yep. And that will get rid of all my data from the environment, just so that I know I'm working fresh. I'm not getting mixed up with anything else. If I want to, I can also get rid of all my plots, and same again, I can do a brush there, and that cleans that up. And also likewise, if I want to, I can clear my history here and clean that up. Just going through some of the other some of the other bits within our data here. Obviously, we had our environment here, which is obviously it contained all our data items. We've got a history, which literally shows you everything that you've run just on a command. Within the console, it shows you the command and obviously the outputs and what governs is going on here. But within the history, there is absolutely literally all the stuff that you've run just command by command. Connections, if you've got it connected up to a data warehouse, this will show you the data warehouse, very much like if you've got this attached to SQL Management Studio, it will show you all the tables, and you can sort of drill down into those tables before you decide to sort of load them in. And there's also something called tutorial, which is really, really cool. You can install a package called LearnR, and it will basically run for you through a bunch of tutorials around various different bits, and it will sort of tell you what to do, and then you sort of run code, etc. So that's kind of what happens up here. Files, we've had a look. Obviously, that just shows you what's in your folder. Obviously, we're up in the cloud, so this is our cloud folder. But if we were on the computer, that would show us our computer. Plots shows us our plots. I just cleaned mine, so I haven't got any in there, but obviously if we did, they would be in there. Packages shows you what packages you have got installed, what version, and what ones are currently running. And you can also use that to update and change those. Help, we did a quick look into the sort of help there. There's also sort of search functions that you can do searches. Viewers, we will come through to when we do later. So sometimes it's not necessarily a plot object you might create. You might create a table, or you might create some other sort of interactive widgety thing, and that will show up within the viewer. And presentation, I'm not entirely sure what presentation does. I will have to find out because that's relatively new. Down here, we've got the console. There is a terminal if you want to use sort of more Linux command line-y stuff to talk to the terminal, but we're not going to do that because that's all Linuxy stuff. And then there's something called background jobs, which will come in later. So when we do installations, it usually flips over to the background jobs and gets those all going. And when we run some Quarto later as well, that will also run as background jobs. So we're going to do final push now. It's 3 o'clock. We're going to go on till about 4. But we will stop, as far as you're concerned, at about 1:45, where we will just do any sort of final wrap-ups of where we got to so far. And also I'll just do some show-offs about, hopefully, a bit of a teaser for some of the prettier and more interesting stuff we're going to do at the end of next, when we get onto the next session. So we're going to chug our way through this. So first of all, we want to load in our libraries, and we're going to basically run through this as a bit of a chug through. So that's loaded in the tidyverse, and it's also loaded in something called NHS datasets. So within NHS datasets, there is a data set called AE attendances. So we want to call that in, and we want to assign it to something called data. So now, when we've called that, we should have data, which is 12,000 observations of 6 variables. And we can click on there and have a very quick look at what that looks like. Always good to have a quick look just with your eyeballs. So what we have is a time series where it's based on a time period. We've got an organization code. We've got type 1 to another. So I assume that's whether it's type 1, type 2s, or type other attendances. And then we've got numbers of attendances, numbers of breaches, and numbers of omissions. So hopefully a really quite simple data set to look at and understand. Hopefully there's nothing too confusing in that lot. But we're going to do a fair amount of stuff with it. So that was looking at it sort of from eyeball. We can do some really super simple things if we want to know the names of the columns, which I often use. We can just do col names data, and it'll get us the names of the columns. I find that really useful then, because then I can copy that and then feed that into another function, because either just to remember what they're called or whatever, or just double check what you've pulled through into your data. And it's just a really nice way to bring up your column names in order to use them elsewhere. We can also look at things like if we want to find the unique data items within a variable. So if we just want to call one column, we can use data and then $type. If you remember when we opened this up, on the little blue arrow, we have data, and then there's this $, and then all the different column titles. So we can basically call our data type, and that will show us that we've got 3 things within our type. We've got number 1, number 2, and other. Just while we are looking at this data, just to confirm that we've got our period, which is already formatted as a date, so we don't have to mess about with changing that as a date. Just to say, we've got a factor type of organization code, which we will come to later about what that means, but basically they are ordered so that they are different, so that when we come to group them together, we're not necessarily grouping on the string factor. There's a sort of layer of data underneath it. Same with the type. So we've got a factor of 1, 2, and other, and automatically the data is ordering it 1, 2, and then other. So it's put it in that order. And then we've got some very basic numerics for these. So we can do some relatively simple things. So we can get the range of a variable, which is really, really quite useful, especially if you've got things for dates. So we can just do range date, and it will tell us obviously the range of the date. Very, very helpful just for having a quick look, make sure that we've got all our bits. We can just instantly see the structure of our data, so see the data type. So we can just do str data, and that will just basically tell us what data types we got. So again, there's pretty much produces this exact view here, but it just means we can bring it up here. So sometimes you can do some calculations and you can somehow coerce your date to being a number, or sometimes when you bring in dates, they don't necessarily come in as a date and it will throw you. So it's a really quick, easy way of just making sure that the structure of your data is coming through as a data. You haven't suddenly turned your numbers into characters and then trying to order them by alphabetical order and things like that, which I'm sure we've all done in various shapes or form. Summary data, we've had a look at that before. So again, that just gives us our very quick eyeball of our data. So we can see our range here. We can also see that we've got obviously a bunch of organization codes, and there's a bunch of others on there. It gives us our frequency of our type 1, 2s and others. So that's all good to know. It gives us our means and medians and maxes. Also good to know that we haven't got any NAs in this data. So that's instantly good to know and good to double check that that's where we are. So a few bits of cleansing and sorting out. So very occasionally you get things like spaces in variable names. This is an absolutely crazy common thing if you're importing from Excel, that people will give it a really nice descriptive column name, but with lots of spaces, and it becomes really, really quite hard to work with. So we're going to coerce some spaces into our data frame and then put them back again. So what we want to do is rename our org code into organization space code. So there's a rename function. So very much like we've done before. So we're going to get our data, and then we're going to feed our rename function into a pipe. So we're going to get our data, and then we're going to rename. And in order to put a space in SQL, you would use square brackets. In R, we're going to use backticks. So we're going to rename, and it's backwards, or it's backwards in my head. So we give it our new name and we tell it it's the old name. So we're going to rename our organization code is going to be our org code. So if we run that, doesn't look like anything particularly exciting has happened. However, now if we just go back to our col names, and we could run that. We can now see we have got a backtick top left of your keyboard next to the 1. Well, it is, yeah, cool. So now if we want to use that, we need to put organization code every time. We'll have to go into backticks, which becomes really, really annoying. So let's now rename some more of our variables into horrible things. So we can put capitals, capital B, we can have one with all in capitals, and we can also put like leading spaces in front of our data. Which is also a really nasty thing to do. Much like Visual Studio Code or Spider, you can press the up arrow in the console to bring back previous bits of code. And there we go. We can see we've got this horrible, horrible, nasty set of column names, which just means it's really, really horrible. As it says there, that's now looking much more like a typical NHS table. So what we want to do is clean all those names to make them useful. So we could go through and do a rename across all of them, or we could call in our janitor. So we have a lovely library called janitor. So let's load that in. And that comes with a lovely function called clean names, which I must admit is one of my, I think when I'm writing new code, it's usually library tidyverse, second line, library janitor, and then loading the data. And then the next thing is clean names. So if we run clean names across our data set, and then if we do our col names, data again, it's got rid of all the trailing, all the leading spaces. It's changed everything into snake case, and has just made it all our bits nice and pretty. So have a quick practice yourself. See if you can change breaches into number space breaches, number space of space breaches. So just have a quick play with that, and then see if you can convert it back again to just breaches. And the other thing is change organization name, organization. Oh, sorry, that should be code, not name. Excuse me, that is incorrect in there. Can you change organization code back to org code? Yeah. So, and as I said, it's kind of backwards. Sorry, I didn't probably explain this very well. So in this example, we're getting our main data set and we're kind of overwriting it, which is generally really bad practice. It's a good idea to keep your main data when you load it in pure as the driven snow, so that you've always got something to roll back to. And then if you do any wrangling, do it on another version until everything's all funky groovy. But keep your main data pure so that if you need to roll back, you don't have to load in all the data again. You can just go back to a version where it's safe. So everything within the environment only exists within R, and the environment within R within memory. You're not necessarily saving stuff, you're not creating stuff on a disk or whatever, so it's not necessarily an issue about space. The only issue about space is potentially your computer memory if you're using really, really, really big data. But then again, I've not had that as a problem per se, so shouldn't be an issue. Not with the size of data sets we're doing. But what we are doing is assigning our data frame to data. So we're actually getting our data and then overwriting it with data. So just be aware that that's what we're doing here. So that hopefully makes sense. So we wanted to rename number of breaches, and that will be our breaches. And then when we look at our col names, we've got this number of breaches. Putting in spaces and stuff is quite useful when we're trying to make like human readable tables. It's actually at some point it does become quite useful to rename our columns, but obviously while we're using our data, not so much. So let's put it back again. So just our breaches. Yes, it should be whatever it was originally, which is org code, not org name. That's a typo on my part. So org code equals, and again, I like just copying it from down here if I've got something. There we go. So we should have period, org code, type, attendances, breaches, admissions as our titles now. All good? Shout if not. If you've got a major problem, you can cheat. You can just run line 7 and line 43, and it will just clean the original names and make them nice, I think. Okie dokie. So let's look at some conditionals. So we want to create a new flag in our data where we've got above 20,000 attendances. Oh my goodness, what's happened there? That's weird. There we go. Weird. Don't know what happened there. So very, very simple syntax. So we've got our data, and then we're going to overwrite our data. I think we stop messing about with our data in a minute, and we're going to mutate because we want a new thing, a new variable, and then we're going to call it above 20,000, and it will be if else. So very, very simple if else. I'm sure you guys have used if else's loads, works in that bog standard way. So if our attendance is greater than or equal 20,000, then yes, otherwise no. And then we can run that through, and we can look on our data, and we can see now we should have a yes no flag based on our attendances. So that should work through. What we can also do is a multi-part conditional, which is a bit like a case, or exactly like a case statement within SQL. So we can do our data, and then we can do an attendance grouping. So we can do where our attendances are less than 5,000, change that to give it a total of less than 5,000, 5 to 9, 10 to 9999, 15, etc., etc. And note that in this instance, our true is our else statement. So a case statement will basically run through each of the options, and it will trigger at the first one it meets. So technically, 1,000 to 12,000 is going to be less than 1,500, but it would always so it will trigger there. I mean, technically it's less than 20,000, but it would have already been taken away from the equation, because it will just get binned at the first bit that it comes to. So if we run that and then have a quick look at our data, we've now got an attendance grouping based on our attendances, and we've created something across all of our data. Okay, so that's kind of useful, but it's not always useful to do it in that way. So in this instance, we've assumed that if it's not less than 25,000, then it's over 25,000, which could cause a problem. So for instance, if we change our first instance to a NA, so I'm changing the original data here, and if we look back on our data now, I've put an NA into our attendances here. So if I rerun this original piece of code here that we were using, due to the logic of the attendances, if it's an NA, it's just going to go, is it NA? Is NA less than 5,000? No. Is NA less than 10,000? No. Is it less than 25,000? No. Else, it's over 25,000. So if we look at our data, I've got an NA, but it's put it in the over 25,000 grouping, which is obviously not where we want it. So it's very dangerous to use the else statement in as a catch-all, because you're always going to get some weird edge case which is gonna mess you up, which we will come to in a minute. So what we can do is be explicit about our groupings. So we can say, is it less than 5,000? Is it less than 10? Blah, 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 blah. Is it over 25,000? Then over 25,000. If it doesn't meet any of those criteria, let's change that to error does not compute. So now when we run this and we look at our data, where we've got our NA now, it's now come through as an error does not compute grouping, which is really, really helpful, because then we can go through and work out what we want to do with that. However, this statement, again, does something a little bit weird. For example, this case statement fails if we've got a result of exactly 25,000, because I wasn't very explicit with my greater than or equals. So I'm going to change that to 25,000. So just to show you what that looks like in my attendances here, I've now got 25,000. And if I rerun my case statement, well, what we would expect to see in my attendance grouping, it's now put my exact 25,000 as an error does not compute. But again, having that error does not compute error kind of a message allows you to sort of go back and go double confirm your logic. So over to you guys. So I'm going to do a bit of a case statement. So I want you to add another column. So that will be another mutate. If it's a type 1, return double the amount of the attendances. If it's a type 2, triple the amount of attendances. If it's a type other, quadruples the number of attendances. And if it's an error, return 9,999 as the result. So does that make sense? Oh, I even put a hint there. So worth double checking the syntax of how that case statement works, as in case when attendance is 50,000 and then the tilde is more or less your then statement, if you think in a SQL way. So if attendance is less than 1,000, then this is your result. So it does work very much like a case statement in SQL, in fact, virtually identically. It's just the syntax is all a little bit backwards. Instead of end as and calling it something, you're kind of creating it within your mutate. So Does help if you can spell. How are we doing? Any problems? So there are potentially a couple of problems you can come out with. Oh, why is that giving it? Why not giving it a name, have I? Okay, so silly me has come up with some issues. So when I did my mutate, I went straight into my case when and didn't give it a column name. So when I've run it, I've gone through and it's just given it a default column name. So that's an issue. So to give it a column name, what are we calling this? I have no idea. Attend multiplier or something. Now when I run it, I should have another column. Yeah. This is the other danger of changing your data on the fly, in that I've still got my old column there and I've created a new one. Is double equals case sensitive? No. Yes, it is. Sorry, yes. So yeah, equality is absolutely case sensitive. No, so yeah, if you've got your other there and you've put a capital O for your other and run it, it will put all your others as 99999. I hope. Yeah, there we go. So yes, equality is case sensitive, so everything has to be just so. So yeah, no worries. Absolutely. So that's good. The other bit of a hopeful mistake that you may have made is putting your 9999 in speech marks, which I think does something funky, if I recall. Is that right? Let's try and remember. Oh no, that's fine. Or is it here? No, that works. There was another one that does something weird. What was it? There we go. Can't, yeah, if you do, is it full speech marks like that? No, can't quite. Oh, have you put attendances ×2 in? So have you done that? I put these in quotes. Is that where you're getting that error? Yeah, there we go. So that is looking at a string that basically is going to pull out a string rather than attendances. So if we do, I'll keep that one as attendances ×4 not in quotes, and I think we'll still get the issue, or will it? No, it won't like that at all. Let's do that one in quotes. So if we did them all in quotes, it will, where are we? There we go. It will actually do the quotes and write attendances ×2, because it's not pulling that through as a variable, it's treating it as a string, which is why if you don't put this as in quotes as well. It's saying, well, I can't add a variable to a number. I don't know what data type I'm going to throw, which is why it's trying to say I can't combine a character and a number. You can't mix data types within a single thing. So that was the one to say. This is where it all gets a little bit complicated, and you just need to make sure that you've got your data types. In fact, look, I even put for your returns, sure they are all of the same data type. Look at me giving you hints. So let's make sure that those are there. And what we've got to remember is where we've got type 1, type 2, and other, as far as R is concerned, type 1 and type 2 are not numbers. They are kind of strings. I will just put the code into the chat, or do you want to post your code to go as well? And we'll see if we can spot the issue. All right, there's my code. Oh, sorted. There we go. Proper job. So fabulous. So that's really cool. And hopefully just shows, you know, you can start doing bits and pieces on there. So like we did before, oh my goodness me, let's just get my data tidy because mine's in a right mess. Let's just run that one. Like we did before, once we've created that column or whatever, we can then do other stuff to it if we so wished, so which is really, really cool. So if we've created this new column where we have our attendances and we've done a grouping, if we wanted to, then we could then filter on that group. So we could filter on our attendance grouping equals less than 5,000 rather than having to do attendances filter by less than 5,000. That makes sense. Hopefully that makes sense. Good. So I don't know why we want to double our attendances and triple our attendances, but it's just to show that you can kind of come out with a result based on something else. I think it was just a kind of show that you can start mixing up your data and doing things with them. So we've done grouping and summarizing before, which is kind of quite cool. But you can also do a group and mutate, which is really, really good at making subtotals and creating data across our groups. So probably easier to show you rather than explain. So what we're going to do is we've got our data and we've got our organization code and our period. So we're going to group it by our organization codes and our period. So for each site and for each month, we are going to calculate the total sum of attendances. And then we are going to divide our attendances by the total number of attendances. So basically, what that will do is group each month and each site and give us a percentage of attendances across the total of attendances for that grouping. So let's just have a look at what that looks like. And I've started at this point now to create new data frames as I go along. So if we look at this data frame, and I've still got a load of pretty things in there. So we look at our organization code here. Where are we? What have we done? We've done an organization code. We have the organization code. What is going on there? That's not what we wanted. Okay. I think I've added something in which I shouldn't have done. Let's just remove where it says period. So let's just remove period. So we're just grouping it by each of the organizations now. Oops, that one. And if we just have a look at our data and we look at it by organisation code, so we've got all this data grouped by the period. We've now got the total number of attendances, which is our attendances all added up for this entire group. So just for this organisation. And then we've done a percentage, which is our attendances divided by the total number of attendances with that grouped. You've ungrouped. Now, wasn't that that is correct. Let's go back to there. That's fine. I need to do an ungroup. Maybe it was type I should have put in. That's what I wanted to do. Sorry, I only wrote this a couple of. So let's look at it by organisation code and type. That's not a good one because it's got loads. But so basically what it's done is taken the organisation code and it's taken all the others. It's created a total across all the attendances for that site, which is this flat number here, and then divided by the attendances by the total to give the percentage attendance for that section. Does that make sense?
Simon, can I just ask another quick question?
Yeah.
Sorry about this, to labour the point, but what would be the implication of not typing the including the final ungroup clause in this block?
It would just give us a warning. It won't actually do anything. It's just good practice. It's then if we came to do something else with that data, so yeah, it's not actually going to change anything. It's just good practice. So it won't change the output at all.
Okay, thanks.
Just if we then use that data set for something else where it's kind of grouped in under there, so it can cause problems. I mean, generally it doesn't, and it's very rare that it does. It's just good practice to make sure that you ungroup. So I've still got my total attendances and sites up. Why is that? That's very strange. Let's change it back to, is it period? I can't remember what the date's called. Yeah, period. That's what I had in there. So that should give me, maybe I need to look at a different organization. Oh no, let's hang on. Let's just go back to the original one again. Let's just run that. Without filtering it. That's how I did it. So now I've done organization code and period. So now what it's done, it's added up for each month by organization code, the attendances of 1, 2, and other. I think when I filtered it, it just made it a little bit more confusing. So now I should have my total attendances will be my 25,813 plus that, which is 25000 plus 813 plus 2850. Oops. Which is my 28663. So it's made a total per month, and then has divided my attendances by my total per month to give me my percentage. So I can see that my type 1, 2s and others, that makes up 87% of my attendances for that month. The type 2s made up 2.8% of the attendances, and the other made up 9.9% of the attendances. That's a better example. I was right in the first place. I just, yeah. Does that work? Does that make sense? Is that all good? Sorry, I need to trust myself that I know what I'm doing occasionally. So that makes a pretty long decimal percentage. Oh, look, I had a thing. Can you round it to 1 decimal place? I think we've done that already. So I'm not going to make you round that. That was more a case of, can you go away and find a function that does round, and a bit of Googling, but we've already covered the round function. And there's a big hint there about being very mindful about your comma, because that is quite a tricky one. Oh my goodness me, we are running short of time. Actually, no, let's just do that as a practice, because I'm just worried the next bit is about pivoting wider and longer, which is like converting our data shape, which gets really, really messy. And we'll save that for an exciting thing to come back to in our next session, because that gets quite complicated. So let's just try this. So we've got a total attendances and a perk attendance. We want to change our perk attendance to only come back with 1 decimal place. So we want to adjust our perk attend to come back with 1 decimal place. And yes, it's really horrible about brackets and commas. Can you use round separately? Yes, you can. Yep. So there's a couple of ways of doing it. You can stick a round statement around this, so you do it all in one, or you can do it quite cheekily, and that you can have it as another thing and have a perk attend, and then just round your perk attend that you've already created. So you kind of overwrite your perk attend. So let's just show both methods. So the all-in-one method would be to add a round statement around that, which gets really quite horrid. And I've put that in there. Is that right? Let's have a check. No, I got that wrong. See, even I mess it up big time. Should have read my own note about being mindful of the comma. There we go. That's popped it in the right place. Or potentially a way of doing it where you don't get messed up by that. So let's just get rid of my round. Is to instantly go over it with how many decimal places? 1. There we go. And you could just feed it into its own sort of pipe and change it and do it separately like that, which, let's have a look at that, comes up with the same result, I believe, hopefully, maybe. And over here, there we go. So horses for courses, really, but nice to know that you can do it in various different ways to do it. Okay, I'm not going to start getting you guys pivoting wider and longer, because that's it's really messy. So I'm just going to whiz through what we're going to look at next time. So we're going to finish off going through this workbook. By all means, if you're absolutely desperate, you can go through it and have a look at it and be teacher's pet for next time and be super fast and ready. I think this pivot wider, longer bit probably does need a bit of explanation, but by all means, it's all commented. Hopefully it'll make sense as you go along. Feel free if you really, really want to. Other than that, we're beginning to look at Quarto. So Quarto is a fab thing where you basically, you reading your data, you doing your analysis, and then you can output this kind of document. What's really, really nice about Quarto, especially in our studio, is that you can feed in several different types of data and also different types of wrangling, and you can mix R and Python in there. So you can actually write Python chunks of code and get it to output into Quarto. So Quarto is really, really cool, and lets you do really, really nice things. So Quarto is basically just an output. I don't know, you guys have done anything in Markdown. You might have done if you've done some GitHub-y things. I don't know. So Markdown's just basically an output language, or a sort of syntax method for producing stuff. And I'm not going to go into that massively now. We'll go through it all more later. I'm just going to show you some of the types of reports that we've got. So this data's got all this output. So this is a standalone output. I've put it into the HSMA Tannoy, and that's just a standalone HTML document, and it's completely self-contained. You can download that and open it, and all the little interactive widgets and stuff that I'm going to show you will work. It means that I can attach this to an email. I can email it to somebody, and they can open it. So it's like sending somebody, just a document that they can use. It's all in HTML5, so it all renders to whatever you've got open. So you can open it on a phone, and even then, all the interactive widgets and everything will work. They might work in a really tiny way, but they will work. So I'm not going to go over this in great detail. I'm just going to show off a couple of the widgets that are in there, so you can mess about with the code, and you can put different codes in there. You can set up headings and bits and pieces. As you see, as I run through the document, there's a table of contents. And as I whiz through the document, it automatically shows me where I am in the document. I can also click on the code, and it will take me back to where I am within the table of contents. You can also sort of make subheadings of contents. So here, where I've got lots of subheadings, you can see now it's expanded to give me my subheadings within my document, which is also really, really cool. And so there's loads of options to mess about with those sort of things. Obviously, you can do things like change all the fonts and italics and strike throughs, put things in lists and do all of that kind of stuff. You can mess about with HTML tags and change your fonts to Comic Sans or whatever, and put things in blocks. You can also make these really, really nice sort of call out blocks with notes and tips and stuff, when you can make sort of interactive collapsible boxes. So, people can click to expand it, or if they're not wanting to have a look. So that's really, really good to sort of like put under a chart if somebody wants to say, for further information, go to. You can insert images. You can insert animated GIFs into your reports, although probably not a great thing to do. You can change the span of your report. So at the moment, obviously it's sort of defaulted to this middle span. If I want to, I can make something go super wide and go across the screen. And what's really, really nice in that this bit now, where I've got it completely across the screen, my table of contents has retreated and hidden until I go past that section, and then it will magically appear again. Look at that magic. So that's really cool. So that's just like some of your basic formatting of your text. So the really nice thing about Quarto is that you can write text, and it's both. So basically, this is an output document, and it's not a template. Or we will run through it and we'll look at how it works. So this is an output document. It's output into HTML, and like I say, I can send this to you as a report. So it's very much about output rather than input. I've included all the R code in it just so that you can see it, and it's here, so you can potentially copy it and paste it in. But you can hide all that and just have it as a standalone report that somebody else can have a look at. And yeah, I'm just going to whiz through it really, really quickly, and we'll go through in much, much more detail next time. So yeah, that's what that is. But like I say, it's very much about sort of your outputs and a report that you want to create, and some of the funky things that you can do with that. Are we doing scatter plots? I'm assuming that's scatter plots. We'll be doing some other sort of plots and bits and pieces next time, and we'll come back to next time in a minute. So we can do some within our report. We can do obviously really, really basic Yes, we can do cataplots. There literally is a Nyan cat cataplot, which we can go into if we really, really want to. But we can create some, obviously, a bog standard line chart, and we can bring those out, which is, you know, quite boring. We can bring out our really, really boring sort of tibbles and produce those. And all right, we're going to do cat plots next week. Or next time, absolutely fine. If we want to, we can make our plot next to our chart and have some text alongside. We can also put sort of plots next to each other and have text underneath that refer to our chart. So that's again really, really nice. We can also add our code into our text. So here I've got some text, but also we can also sort of run it and see that it's actually input some data itself. So today's date is the 13th of February, which is when I wrote this thing, and I haven't updated it since, so bad me. I shouldn't say that's today's date when I ran this is today's date, and obviously that's static as at the point that I've run it. And then I've got something here where I've done an English statement, and I've done a case when, depending on the date of the week, and then it will spit out, so you can mix and match code into your text. So here I've got, you can pull data from data frames such as the highest amount of attendances in our data set was 32,209, and that's pulled from the data set. That's not me typing it in that there was 32,000. I've mixed and matched the code and bring it into the data set, into my report, which again makes, if you're actually sort of writing a report and want to send it out to people, you can really convert things into English, and people like English reports. That's really good. Another really nice thing that we can do is we can have two plots next to each other, and we can have them on two different tab sets, so we can like ping from one to another, and you can set up lots and lots of different tab sets with different types of plots, or you can have the plot and a table, or various different things like that. So that's all quite nice. We can do various different types of tables, so we can make our tables look a little bit nicer. We can make sort of nice tables with indents and grouping and lines and conditional formatting and all of that kind of stuff. But I think where we start getting a little bit nicer is when we start making things that little bit more interactive. So we can do nice tables, and we can put in little bar charts and things within our tables, not sparklines, because sparklines are evil, but we can put little sort of mini plots and things in there. But then we start getting into the more sort of interactive stuff. So here I've got my data table, and what I can do is I can click on here and I can filter my data table here, and it will automatically adjust. If I want to filter it to a single organization, I can filter that through. I can also turn my filters off if I so wish. I can change this all to type 1s. And I can just copy and sort and go through my data. If I want to, I could press on attendances and order my data as I wish. So it's just giving somebody a data table they can mess with. At the moment, I've got it defaulted to show 10 entries. If I want to, I can expand that to show 25. So now I've got sort of a much bigger data table, and that's just expanded automatically to fill that in. Let's go back to 10. And what I can do as well with my filtered data, if I want to, I can press copy, and that will copy it onto the clipboard. I can press CSV, and that will download a CSV version of the data as at the point I filtered it to. So at the moment, it's going to filter. If I press CSV, it will save me a copy of type 1s for this period and whatever here. So that's really cool. I can also save this table as a PDF or just like straight to print, which is quite nice. So that's just including a data table for people to look at. And again, I can go through and I can click and see the different bits within that if I want. So that's a nice way of showing a data table. Another type of data table that you can do is sort of a reactive data table, where so this is using the same data set that we've been playing with, and at the moment it's sort of aggregated up to the period, but we can then drill down to work out the median attendances overall in March was this, and then we could break it down by each of the different types. And if we really want to, we could drill another level and see it at each of the organizations, and you can drill that. So it's, again, if you've got kind of quite nice hierarchical data, it's very nice to sort of show that top level and then be able to drill down into individual teams or whatever. And all this stuff around the median attendances and the sort of max breaches and mean admissions, again, is all built within the table. So we've not had to calculate those separately. Those are just sort of built within the table function, which is quite nice. So Plotly is quite nice. So here's here's a plot that we had earlier, exactly the same plot. However, this one is now interactive, so we can sort of hover over it and it will give us those sort of tooltips. We can click on traces and turn them on and off if we so wish. If we want to, we can click and drag across an area, and that will zoom in to that area if we so wish. And then if we wanted to, we could take a screenshot of that zoom and it would save that, or we can bring that back in. We can tell it to do multi-line comparison. So now we are sort of comparing each of those data points across each of those areas. And like I say, we'll show you the code for that, though, is super fabulous. So we've already created a plot, and then we want to convert it to sorry, it's all going very strange there, to a GG plot Plotly. So it's just literally one line of code and it will create us a plot. And again, we can sort of create box plots of stuff. And again, it's really nice if we've got all these different things that we can then do a zoom in and have a look at what those individual box plots look like. We've also got some really nice hover overs where we can look at that and it will tell us our means and our quartiles on a box plot just by a hover over, which is really nice. Getting into the just because you can doesn't mean you should area. I'm very mindful of time. Oh, let's not go into that one yet. We can do animated plots over time. That's not coming through very smoothly on my screen. I guess that's because I've got 500 things running. But have a go at it on your own, and it should come through really nice and smooth, and it goes all wibbly wobbly across the screen. Fabulous. And you've got this little slider then which you can go forwards and back into time if you so wish. Boop. Which is nice. Another crazy thing you can do if you really want to is, based on that data that we had, we could map our admissions, breaches and attendances on a scatter plot and make that a 3D plot, which we can then zoom around and spin around on. It's making me dizzy just looking at it. And you can sort of zoom in and out and do all manner of crazy things and sort of spin it around some more. Not entirely sure why, but hey, why not? So yeah, please don't make 3D graphs and send those out, but you can, and some of those are quite useful. Another really good thing for if you've got time series is something called digraphs, which allows you to sort of zoom into a specific area of a time series if you so wished. Doesn't really explain it very well here, but I've got a little one, and that's just given me a rolling window for median. So I can change that to 3, and that will just sort of smooth the data on the fly to show me what my new median, sorry, my smoothed data looks like. I'm not going to go into that more now. You can do nice little funky survey plots. So do you like stuff? And you can do these like strongly agree, disagree type plots. Those are really quite easy to come out with. We can do tree maps, which is like an alternative to a pie chart. So we can look at our RH1 and our RH4, and we can see our proportion of attendances by one to another. But this is also interactive as well. So if we click on our RH1, that will expand out, and then we can look at our RH1 in much more detail, and then we can sort of go back a level if we so wish, and then click on our RH4 and see what that looks like, and go back. Obviously, this is on a really simple example. You can set it up so you can have hierarchies within hierarchies within hierarchies. So if you want to look at comparisons of types across different things, that becomes really easy. And obviously, that's much nicer than trying to do the same on a pie chart. If you want to do something like show pathways through a system, a really nice way of doing that is a sort of a dendrogram. And again, this is all sort of built on the fly. So we can look at our base data, and then we can expand out. So in RK9, what proportion went to one to another? And then if we so wish, we can then sort of work out from those, whether that's attendances, breaches, or whatever. And you can click and you can play on those. And I love playing with these because it's very pretty. So you can kind of really good for sort of mapping pathways and sort of showing thing. Yeah, how do I open this in my browser? Literally just open it in anything that's not Internet Explorer. You should probably have to download it from the Slack, and then open it, and it will just open. And you can play with all of these bits. We can do like funky heat maps. So this is showing measles, and this is when they introduced the vaccine, the measles vaccine. So it's obviously each of these is the individual country. This is definitely one where the sort of zoom in comes in handy. So we can sort of zoom into areas and see what impact it had in these areas. So this is numbers of cases as a heat map over time. And then this is where they introduce the vaccine, and we can see instantly that sort of drop off. And we've also got these sort of like side bars of additional charts as well, which again are sort of all hover overable, which is really, really nice. We can make plotly plots where we can basically, instead of having them all on one chart, we can sort of go from one to another and create little drop downs, so you can choose which site you want to do. We can make maps with leaflets. So just a very, very simple one here. Yes, he is supposed to be spinning around, just because there was an option in the code and I didn't know what it said. Where was it? Where is it? Yeah, there was an option for spin. And I was like, what does that mean? And it says spin is true. So I thought, let's see what that does and spin. And as you can see, it makes the little icon spin, which is completely useless. But we can zoom in and out on our icon. Are the wide and span the same syntax as in Markdown? No, the syntax is slightly different than our Markdown. But we can sort of click and drag our thing. We can also have different layers on our maps, so we can sort of turn them on and off as they wish. We're nearly there. We can create word clouds. So let's get past all that because there's a lot of stuff in there. So there's a little word cloud there, which is based off some data we feed in. And this is, again, is sort of also interactive, so you can sort of hover over and see what your frequencies are for each of your words. So that's quite nice. Hopefully you can work out what the original book that I stole that from. All the codes in there about, I think you've done some text processing, you probably have with Dan, about how to remove stop words and various different bits and pieces. You can create something called mermaid diagrams. This isn't part of R, this is part of Quattro, but allows you to make really, really quite nice sort of flowcharts and bits and pieces in a really relatively simple way. So you can do very simple, just one to another decisions and outputs, or you can make these much, much more sort of complex type stuff in there. Or there is something called graph viz networks as well, which also allows you to make flowcharts. I've not explored that one so well because I like Mermaid so much, but looks like it does a very similar sort of thing. And then I think finally we've got our pivot table, which I think is one of my favorite little widgets, where you can give it a data set and give it a kind of a really nice sort of pivot table where you can sort of hand out your data to your customers, and they can have a little bit of a play of it in a pivot table-y way, but hopefully not so dangerous. So you can, at the moment, I've got org code and type. If I move, I can click and drag that, and it will change that to type. If I wanted to, I could bring in my period, and then it would show it in a wider format there. I can scroll across and have a look, but I'm not going to. If I want to, I can then filter this down and remove the type 2s if I wanted to. Rather than a count, I could change that to the median of attendances. So one of my big bugbears in Excel is that you can't do a median in a pivot table, whereas this just does, which is nice. At the moment, obviously, we've got it in a table here, but maybe we don't want it in a table. Maybe I want it in a bar chart. And it should, if it's not, there we go. It will convert it into a little bar chart for me, and it does all manner of different things. There's loads of options. We can do a little heat map if needs be. Anyway, and all of that is basically on one line of code there, which creates this widget, which you can then play with. So we will go through some more wrangling. I think we're going to run through how to do SPC charts. I'm going to run through how this report runs and works, and there's sort of the code available to do that, how to do sort of funky outputs. And probably if you've got any sort of specific bits and pieces that you want us to cover, ping me in the Slack and I'll have a look at it next week, and I'll see if there's anything specifically we need to develop and go on to. So next week we will, not next week, I think it's 2 weeks. We'll go through some more advanced wrangling and bits and pieces, finish off that worksheet. We'll run through some of this output-y stuff, because it's really nice to have a really nice sort of output of whatever you're producing, unless you're going to put it into some sort of BI tool or something. We'll cover where to go for more information and next steps if you want to learn more about R. And yeah, and then we'll just have any other questions. Cool. Yeah, any questions before I drop off for today? Or comments or anything? Deathly silence. And now fuzzy. Do we need to do the work from today for next session? Do you want homework? I don't know. I guess if you can run through the rest of that document, the code, I think that might be helpful, and then we can run through it if there's any questions or queries, or if anybody got stuck. I think each of the bits from there on in are self-contained, so long as you've run the data at the top and remember to call whatever it is org code, you should be able to just run each of the separate sections on their own and have a play with them. But yeah, we can go through. So yeah, if you want to do that as homework, and then put in the chat or put in the Slack if there's any extra bits that you want us to cover, I guess that will give us a bit more time to do other bits if you want to do other bits. Okie dokie, blimey. Right, I need to go and do some work. Right, let's stop recording so you can all start swearing at me. Where's that button? Stop share.
Thanks, Simon.
No worries.
Thanks, Simon.
No problem.
Thank you. Bye-bye.
Cheers.
It's really good.
Thanks very much.
Bye. Much better than that rubbish Python. Tell Dan I said that. Yeah, in fact, everybody has to go back down and say, Dan, why don't we learn R?
Thanks, Simon. Bye.
Cheers.
Agreed.
Don't think Dan would be very happy. Right. All right, I'm off. Thank you very much, guys.